So the way, as I mentioned each day, the way I like to do this is kind of, if you have questions that are probably more pertinent than me going off on a particular path that is less relevant. So first thing let's do is just actually, if you guys have any questions about what we've talked about before, now is a really good time to discuss them. And as I mentioned before, if you have a question, I guarantee you everyone else will benefit from an explanation of it. Okay, this stuff, as I was just talking with Pamela, this stuff is kind of fundamental. That doesn't mean it's elementary. It doesn't mean it's trivial. It means that it's actually just important. And some of it's very advanced. Okay, not hard, but advanced in the sense that you can use R without it, but it's much easier if you know how R works so that you can actually read that. So does anyone have any questions? No? I was that confusing that there was, you can't even articulate a question about it?
You're saying, so if you pass math 1 plus 1,
yeah,
that can actually experiment to cause some fun, right?
Okay, 1 plus 1 is parsed, and again, you don't have to do this. I'm just explaining that you can, and it's very helpful for your edification when things are just inexplicable to you. This gets, if you parse this, it comes out as this, okay, as a call to plus. So not a call to sum, but a call to plus. Okay, and with these two arguments. And if I put pi in here, it will be pi in here, and this will lead to a different evaluation, but again, according to the same model. Yep, so that's what we get.
So is the parser, that's my question, is it the parser that does that, or the quantitative evaluator?
It's the parser that does that, and you can tell this because you can call parse, you can say parse text equals this guy, and then you actually will get back, and you will get back a call, essentially, okay? And we talk about expressions, and they're a little bit weird, okay? Expressions, so sometimes we also have things like this, where we sort of say, here's 3 expressions, x equals 1, y equals 2, x plus y. And this is a sequence of 3 assignments, which are actually calls, because everything in R essentially is a call to a function. In this case, the function is equals. You know, you can redefine almost everything, but this comes back as an expression when you parse it, but then we can walk through, and the first element strangely is this guy, and then we can pull out the individual elements. It's just a list, okay? And likewise, when we parse this, we get a call back, and then we can take a look, and this is the first element, and then the rest of them are all the arguments. They have names. So if somebody makes a call to a function that says, you know, plot, and they say x comma y, and then they say main equals this, and they say x lab equals z. We'll see the names, we'll see this call, we'll see all of these are actually named elements. These are names. This is a literal value, and this is another name element, which we will then evaluate. But it's a very good, it's not important that you know this until it becomes important, okay, until you're having trouble. When you do need to know it, it's very useful to know it's the parser that's turning these into the calls. The evaluator is just responsible for evaluating each call. And again, what it does is, starting in the relevant environment, it starts looking for the plus function, because it knows this is a call to plus. So it looks for a symbol named plus, which is a function. Got it. Sets up the call frame because it knows now all the parameters in there. Then it starts matching the arguments to the parameters, and then it starts executing the body of the function, so each line at a time. And where does it start from? It starts looking in the call frame for all of those variables. That's why it'll find the parameters and any local variable that you've created there. And if it can't find something there, it starts looking in the parent environment of the call frame, and blah, 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 blah. Up we go. And it's a nice, clean, simple model. But that's the evaluator. The parser is the guy that sort of constructs things. And one of the reasons it's kind of useful, again, very few people do this. Some of us do it for a living, okay, is that I can actually construct objects. I can construct objects in my function that I can then pass to the evaluator. Okay, so I don't have to parse them or anything like that, but I'm mimicking what the parser does. So you'll see, sometimes you'll see code like substitute of x equals y, that's fine. Okay, well, we'll do this, x gets y. And then what people will do is they say, oh, and by the way, I would like you to replace y with this value z. And whatever z is, we'll get it put into y, okay? So this is a useful thing to be able to do, to be able to actually change computations on the fly, okay? But then we're just constructing what the parser would do, but in a better way, and then handing it off to the evaluator. That's the difference between the parser and constructing these things manual, but then they're all feeding into the evaluator. Okay, these calls. Happy ones? Anything else? So just a quick recap, just to make sure that you should have questions. Okay, what are we doing? We talked about the recycling rule. Okay, this is very important. A lot of the times you don't care about it. A lot of the times you've got a vector that looks like this, and you've got a simple scalar value, and you don't even think about it. It just works the way it's supposed to work. But if this is, remember, this is an object of length 2, and we're doing some operation. And remember, almost everything in R is vectorized. So if we're doing some operation, the implicit rule, unless it's not in effect, but it's 99% of the time it is in effect, we make this one, the smaller one, the same length as this guy, which means we repeat. We literally do the equivalent of repeat the small one, so that the length is equal to the length of the big one. Okay, and that's great. This actually works out to be a very, very sensible way of thinking about life for most parts, but in some cases it doesn't, and you get warnings if you're lucky enough when this is not a factor of the length of this one. But if they are, and it just happens to be the wrong thing, you're going to potentially end up with the wrong idea. So we talked about vectorization a lot. Okay, so you really want to be in. There's a lot of functions in R that are plus, ampersand, and all these other ones, and sum, and all these, which are heavily vectorized. And these are our primitive building blocks. You can do an awful lot with those, and therefore, essentially, almost everything else is vectorized. So a lot of primitive operations are vectorized. If you use those, you get vectorized operations. There's some that you can't, but you really want to be trying to exploit those because they're the super fast versions of absolutely everything. So you kind of always try, and then you always want to be thinking that I use the recycling rule, and then I do element-wise operations, and that leads me to a new operation that is the same length with the results of combining each of those two together, each collection of elements. And sometimes when the actual function to combine these is not vectorized, we're going to use another function called mapply to do this. Okay, and we'll get there in a minute. Okay, so that in that regard, life is good. And then we've got these other ones, which are things like sum and product and other things, which are basically, these go down into a single scalar value. Okay, so they're still vectorized in their inputs, but they don't give back a vector of the same length. They give you back what you want. And again, you really want to be exploiting these, because if you have to write something with a for loop or something else, you're just getting slow. So you have to, yeah.
But you said that in that recycling group, actually the R will not duplicate, right? So
it depends on the function, but for the most part, the built-in functions are smart enough to actually. So just to be clear, some of the C code that works on this actually basically just goes modulo the length of this thing. Okay, so it just basically it wraps itself around. So when it starts off, it gets number 1, then it gets number 2, and then it figures out it needs number 3. So it actually in the code it maps itself back onto 1. Okay. For the most part, conceptually, you want to think about it actually repeating. Okay, just like I said, also conceptually, you want to think that when an argument is passed into a function, that it's lazily evaluated, so it does not get nothing happens until it's needed. But you want to conceptually think that when it's needed, it gets copied. Okay. Doesn't always, but you want to, that's the model, so that you want to think, because that sort of says any changes after that are to the copy, not to the original one, so the caller can't see this. R is trying to be clever and efficient, so it doesn't actually make a copy, but there are times when it can't know that that's the right thing to do. So it actually then has to be very cautious. Okay. Clark, you had a question?
That was my question.
Okay. Which, about the copy?
Yeah.
Yeah, so it's this thing called copy on write, to be technical about it. What happens is that when you pass in, when I do something like, so let's just say I call plot of x and y, and suppose the plot function actually does something. Let's just say x equals is not dot x. Okay, we'll do something. Well, actually, let's do this. Let's do x such that is dot na of x equals 0. Okay, so now I'm modifying x. Okay, so when x comes in here, so this we've called plot of x, y. Okay, so let's call it a and b. Okay, so this is my call, plot a and b. In the plot function, the parameters are actually x and y. So these get mapped, a gets mapped to x and b gets mapped to y. So now in the body of the code for plot, we get x, we get this sign. X is now being changed in the local call frame, okay? So now, and only now, will R actually make a copy of X, of A essentially, should I say, okay? This is what it's sitting around. This is a big long vector. And we do things like this. We say sum of X, you know, we get an answer, or we get the min and the maximum of X to find out the plotting limits. No problem. We will never copy A at that point because there's no need to. Nobody's changed A. The second we change A, which is now sort of, you know, an alias for X is an alias for A. The second we change that in the local frame, we have to separate these and say, here's the new copy of X. Okay, and this is a thing called copy on write. Okay, which because it's only because we're changing X that we actually have to make a copy of A. And that's basically what happens in R most of the time. There's a magic trick that if you do something like this, if you do basically things like X of this guy, in some cases R can see that you're going to write back on top of X, so it can actually say, you know what, that's okay. I'm going to reuse the memory from X to actually change this X. You never count on that. Okay, it's a very special optimization. Okay, so that's that was what we're talking about. So the other thing we were talking about. So what we've been talking a lot about is vectors. So copy on write. Okay, the recycling rule. These are all good things to know about. The other thing we mentioned was this whole business of. So we have a list. Okay, so we have all these vectors, and we have listed. I put it in my notes. Thank you for those of you who've actually pointed out some link problems and stuff like that. Thank you. And missing sentences, very helpful. Did I tell you how to construct a list of length 10? I don't think I did. How do you construct a list of length 10? How do you construct an integer vector of length 10? Integer 10. So how do I construct a list of length 10? Everyone happy? That won't work. That's going to be a list with one element whose value is 10. This is an integer vector with 10 elements because it's clear that we're not sort of saying make this an integer with value 10. Okay, that's just a definition. Here we actually need a mechanism to actually construct a list with this many elements. Okay, so what we can actually do is we can say vector of list with 10 elements, okay? So this is a different constructor function altogether. You could actually say vector integer 10, and it would be the same as this guy, no problem. But there's a conceptual issue here is I need to construct a list with 10 elements ahead of time. So, and I'm not gonna type it out. Change 10 to be 1,000,000. I'm not gonna type an out list of null, 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 okay? So I need to be able to construct this. But the way R thinks about this is it says, no, this is a list with just one element whose value is 10, okay? Which is a very different ballgame. So there's the concept of, so this emphasizes the fact that vectors and lists are actually one and the same. They're just an ordered collection of elements. But remember, lists can have, if we have a list like this, we can have anything in here. There's no connection between between these elements. They're just, except for the fact that they're ordered, okay? And this one comes after this, and they may have names and so forth. The vectors, they all have to have exactly the same data types in each cell, and R will ensure that that happens. So therefore, integers will get coerced up to numeric values and character vectors and so forth. And this is often what you don't want to have happen. And in my notes, there's a big difference between this, C of X and Y, and list of X and Y. Because if these are two vectors, R will try to actually concatenate them together. So if this is a vector that looks like this, and this is a vector that looks like this, it will treat them like that and say, oh, look, I can make it one big long vector. Whereas this statement is basically saying I want to list two elements, X and Y, and that's why this works. Okay, so C and list is a very common mistake that people make is, I can save 3 characters by typing C instead of list, and it almost does the same thing most of the time, but not all the time, and it can be very bad news, okay? And then, so we talked about the vectors and lists. So these guys are very important. You can do anything you want with these. You can put anything. You can put a vector. You can put a collection of numbers, an integer vector, as a list, but it's really unhelpful because you can't add them together or anything like that. But you can easily unlist them. You can always just say, okay, destroy the characters, destroy the hierarchical nature, and collapse it down to a vector, and then life is good again. But you kind of, all these operations that I have, like the log and stuff, will not really behave well on a list. Okay, they'll do something weird to it, and so they may coerce it back to a vector. But you do want to be able to figure things out. And then the other big guy was a data frame. Okay, and again, there's very little to this. The only thing about a data frame, it's a list. Treat it as a list if you want. Otherwise, treat it as a two-dimensional thing. You can schizophrenically go between the two because it's very convenient. Okay. And then we've got these operators, the square bracket, the double square bracket, and the $sign. And if I was giving a quiz now, which one does partial matching on names? Brackets? $sign. Which double square bracket? This guy, okay. This one does partial name matching on a list. Okay, partial name matching on variables, but it doesn't evaluate its right-hand side. So it will look for a variable named var here, or if $I, it'll look for I, but it will not look in the variable named I and then get its value as a string and then try to find the variable there. So this is convenient for interactive use. This guy does not do partial matching, but it does. If I type var in here, it will actually look up the value of var, get the value of it as a string, and then say, now I'm looking for that guy. So if var is a string, that's great. So if var turns out to be ABC, it'll find a variable named ABC and not something called ABCD. But if var happens to be the value 2, it'll work just as well, okay? Because it'll now look for 2, because we have subsetting by index or by name or so forth, okay? And then this guy is used for lists and for vectors. Remember, this guy here gives us back one element, okay? Then that's it. It extracts a value from a list. This guy over here gives you back an object of the same class, okay, as the thing being subsetted, which means you can't get back the first element of a list, okay? All well and good. So, and I left you with, and I also told you that you really should be exploiting the logical subsetting. A lot of people do this, and there are times when it's important. You know, people do things like x is greater than 0. Let's find all the x's that are greater than 0, and then we go to a parallel vector y, and we go get this, and we see a lot of this guy doing which of x greater than 0, and that's absolutely fine. Okay, it's just an extra piece of work. Okay, but these two are the same things. Why make it more complicated? Okay, and this works. Okay, there's kind of this funky thing. What happens if x is empty? You've got to worry about these corner cases. You have to worry about these corner cases when you're programming. Okay, that means when you're writing a function for yourself. Okay, you have to be careful about these different things. Okay, that's fine. So what if you do this? If I have a list. Okay, I have a list, and so somehow magically I have a list that looks like this. It's got some elements. And I want to basically, and I get a corresponding, I don't know how, but I got a corresponding, this is true, this is false. And again, we always use capital TRUE, not the variables T and F. I got false here, okay, and so forth, and true. How do I get out, let's just say this is all false. How do I get out that one element that is true from the list? Double bracket, what? Fourth, well, I have to know which one. So I could actually say which of this and get the fourth one. And that for a list, if I now go in here and do my list of this guy and put in the logical vector, this won't behave itself right. Okay, so in this case, we do actually have to say which. We have to go in and tell it because we want one element. It's R can't guarantee without looking at this trues and falses that there is only one element in here. So it basically says this is a bad idea. Actually going in and finding one element using a logical vector is not a good idea. Okay, so in that case, we'd actually go off and say which one is correct. And if there's two of them, remember, so if I remember I had it true here, so let's put two of them in here. Two of them are true. This double square bracket is guaranteed to get me back what? One element. So this kind of doesn't make sense. What's worse is if I type which on this guy, what will I get back? True, false, false, true, false. Which ones are true? So I'll get back 1 and 4. So what will go in here is 1 and 4, which means I'll go and get the first element and then get the fourth element of that first element, which may be an error, may be correct. But if I expected only 1 to be true, I've got a totally different computation going on here. Okay, and the code can still run, but give you totally unexpected answers, okay? So there's a lot of stuff that can go wrong here, okay? So one of the reasons for this is, telling you about this is that you have to start being protective against your code and you actually know what it is. This is one of the reasons why I mentioned earlier on, I tend to actually write this computation and then test it. Just check how many are true or false. You know, I get logical values like this and I just type table, which gives me a count of the trues and the falses, all the unique elements. And if that's not 1, I go, something's wrong here, okay? So you're always trying to make sure that things are what you expect. And this is when you're doing this interactively. And when you're not doing it interactively, you better put these checks into your code, okay? So that's the idea. Okay. So again, all of this is elementary to some extent, except for there's so much that can go wrong. I mean, it's easy to know the rules here about whether this is partial matching or not. It's easy to find out. It's really worthwhile to go through and look at all the corner cases where you basically say x equals numeric here with 0 elements. What does x greater than 0 give me back? Does it give me back a logical value? Okay, it does give you back a logical vector. What length? It should be the same length as this because of the vectorization. So that means we should get back an empty logical. What happens when you subset by an empty logical? It all basically behaves as I hope you would anticipate. I did find an interesting thing, which I forgot, which I was thinking of something else. What does that give you? Any is a function that takes only a logical vector, and it basically says if any of the elements are true, I'm true. But if none of them are true, then I'll give you back false. So this is guaranteed to give me back a scalar. Well, not if. What happens if you give it an empty vector? It's false. Now this is a corner case. It could easily be defined as sort of a logical 0 to be the same length as this, but this isn't vectorized. This is actually, it's vectorized, but it's one like the sum function. It gives you back an aggregate. It doesn't give you back one value for each element in the input. So it's not constrained in some sense to give you back the same length as this. Therefore, it has to give you back something intelligent. So it's like sort of this NA business. You know, what's adding 1 to an NA? What do I get? Well, I get an NA. This is a scalar, so this gives you back false. So you give it something of length 1, and all of a sudden it's become length 0. So you start with something with length 0, and you've now got something with length 1. And this can be slightly odd, okay? That's fine. And I can't remember, but because I don't think I showed you this either. Just again, just trying to show you some gotchas. A lot of people do this sort of thing, 1 through n. Okay, and what they really mean is 1 through the length of x. Okay, so what's wrong with this? Pardon?
If there is a null vector.
If which isn't?
If the vector x is null,
so if this is empty, if x is empty, n is what? Okay, so we replace this with 0. So this is what, 1 through 0, which is? How many elements are in 1 through 0? 2. We get back C of 1 and 0. So instead of looping, which is often what is the case, instead of looping over no elements, you've looped over 2 elements. And you typically going in, you're sort of saying, give me x square bracket I for I in this guy. X square bracket I, give me the first one, which I didn't want in the first place at all because there was none of them. Well, so this is a missing value, okay? And then the next one is, well, remember we're subsetting with 0, which says don't do anything at all. So you get back an empty vector, and then now anything that I do on that is now working on it, not on a scalar value, but on an empty vector. So this is very bad. So what will we replace this with? Whenever we see this, what do we replace it by? Same problem, exactly the same problem. Length and n row is for two-dimensional structure, just telling how many observations. But if there's none, and I can have a data frame with absolutely no observations in it, but a whole lot of columns with no observations, so this would give me the same issue. So what we actually need is this, and there's various versions of it. We need to create a sequence, but we need to say it's along x, and that knows that if x is empty, this thing comes back with an empty integer vector, okay? So this guy comes back as being integer, the same thing as integer 0, and if I try to loop over that or anything like that, life will be good, okay? So this is, whenever you see 1 through n, where this is the length of x, okay, or directly inside it or assigned, and then you nearly always mean this, sequence along equals x. Okay, this is one of the most common bugs, and you go like, wow, why am I looping over 2 things? Because you told me to. Yeah. So
you would change then n equals sequence along x and then keep your loop.
I remove all of that. Thank you. Until asked, I tend to be sort of, you know, everyone understands. So and the details matter. So when you see something like this for I in 1 through n, and we try to avoid loops, but it's not just that. We can, if I say sapply, we'll talk about sapply in a minute. Sapply of 1 through n. Okay, and I'm going to say n here, where n is, I've assigned n here. Or if you just see it in place, length of x, whenever you see that, alarm bells go off, okay? This is not going to work, okay? N row of x, okay, same deal, okay? Why does this cause grief, okay? When you're sitting there interactively, no problem, this is all going to behave itself. Okay, when then you go off and do something which is you have a large data frame. So again, no problem, everything's fine. And then you say, now, I'd like you to group by these different groups. And then I'd like you to do something to them, okay, to each group. One of those groups, on some occasion, will actually end up with no observations in it. And now you're toast, okay? Because now you're going to go off and actually say 1 through the number of observations in this group. There aren't any. Now, it's only 1 of 12 million groups, but that's your problem. So it's not that your overall data set has no observations. It's just that some weird subsetting that you do. So it's not just like, give me all the people who are from the different states. And we always have 1 from each state. No, give me all the people from each state whose age is greater than 50, whose median income is minus 150,000. You go like, nobody there, okay? And all of a sudden, all your code goes kind of awry. Okay, so when you see this, this is always followed by, this is always replaced by, for I in seek along equals x. So not the length of x, but x. Okay, if you put in the length of x, what would you get? 1. Because length of x is a vector of length 1. So we're saying along, just take the, it's basically saying take that vector. So if you put in length of x here, R doesn't know what to do, okay? There are these other things, there's other commands like seek len. There's all sorts of different ways of creating a sequence. Unfortunately, this is just so convenient and so wrong, okay? In all but 99% of the time, it's right. It's just the time that, and then 2 weeks of your life later, you go, oh, that's why. And I've learned absolutely nothing, okay? So these are good things. I have a question for you. I want to, so going back onto vectorization again, and then we're, okay, you really want to exhaust vectorization. Everything that R can do that's vectorized, use it, because it's super fast. So I want to generate a sample of, I'm going to keep this simple, and hopefully some of you have seen this, okay? I want a sample, okay? I want to actually generate a sample, and seeing as, why not, we're just using a standard normal, okay? Well, not quite, okay? I want to generate a sample from n with mu1 and sigma 1. Okay, I want n1 of those guys, and I got n of mu2 and sigma 2, and I want n2 of those guys, and so forth. Okay? How am I going to vectorize that? I need to basically generate 10 values from a normal with mean 10, and well, 10 values from a standard normal, 100 values from a normal with mean 100 and standard deviation 2, and I need another 30 values from some other, with other values of mu and sigma. I would really like to vectorize this. For those of you who care, this is, this is often comes from a mixture model, okay, where we actually have different distributions that all come together there, okay, that we choose at random with different probabilities from the different distributions, and that defines an overall distribution, okay? How do I do this? How do I vectorize this? Because the simple thing to do is just to actually issue this command, because we do have this function rnorm. Okay, and if you're not familiar with it, by the way, we also have R exponential, R Cauchy, okay, and so forth. For most of the common random variables, we have a function with the name of the random variable preceded by an R, which means generate a random sample from that distribution. And by the way, I'll give you the parameters for that distribution. For a normal, we give the mean and mu. For an exponential, we just need a scale parameter. For Cauchy, I think we need two parameters, and so forth. So there's this thing in R, there's R followed by the name of a random variable is the random number generation. D followed by the name of the random variable is the density of that random variable evaluated at certain x's. Then we also have Q and we also have P. P is the CDF, Q is the quantile. How to compute quantiles from this distribution. The CDF is the cumulative distribution function. And if you ever want to write, if you ever need to deal with another random variable, you should write these functions so that everyone knows what they are. And there's a bunch of them in different packages and so forth. And they all adhere to this convention, ideally, okay, RPQD. Okay. How do I generate? So one of the ways to do this is to call rnorm with n1, and I put in mu1 and sigma 1. And then I do the next one, which is rnorm of n2 and mu1 and sigma 1, yes? And what I'm going to do is I'm going to put a C around these because I want to flatten them out. I do the third one. Everyone happy? Okay, so I'm just going to generate, n1 values here, then another n2 values here, then another n3 values here. I can keep them separate, but I want to combine them all into one big vector so I can plot them. How do I vectorize that? How do I get rid of those 3 commands and make them into one command?
You said apply, right?
I can do that, but I haven't got there yet. I really want to exploit R's functionality. Okay, I can use mapply, and I will do that. We can do this in a moment. But in this particular case, I can do something slightly different.
You just pass a vector to use to first.
Okay, this is a very useful little trick for people who are doing any sort of simulation or MCMC or anything like that. rnorm and some other functions, many of these other functions, but other functions as well. I'm just using these as an example. They're rare, but when they exist, you really want to exploit them. Some of these functions work the following way, which is when you say rnorm and I'm going to give it now n1 plus n2 plus n3, okay? And I'm basically going to give it a big long vector. And I'm going to give it a big long vector of okay, this is the mu and this is the sigma. And I'm going to basically have the same value repeated multiple times. I'm going to have it repeated n1 times for mu1. Okay, so let's make this 0, let's make this 10, and let's make this 30. Okay, and let's make n1 to be 5, and let's make this to be 7, and make this to be 13. By the way, these are really good test cases. Prime numbers, relatively prime numbers, allow you to decompose what the heck's going on and avoid the recycling rule and so forth, or oddities from the recycling rule. So basically what I can do is I can say rep. What can I rep? I'm going to rep 0, 10, and 30. How many times? 5, 7, and 13. Okay, and that will replicate 0 5 times, 10 7 times, and 30 13 times. Okay, to give me this vector here. And I'll do the same thing with the sigma. Okay, and now what R will do is it's vectorized not in this argument, it's vectorized in these arguments. So it'll generate a random value with these two parameters. Then it'll move on to the next one and generate a random value from a normal distribution with this mean, and that's standard deviation, and so forth. Okay. By the way, what happens if I put in this? What happens if I just put in the value 3 here? It's vectorized in this argument. It's also, so the recycling rule comes in here. It's vectorized in both arguments, so it has to make this one as big as this one, again, conceptually. And then it will actually just replicate this out to be the same length. So it'll be constant for all of them. But if I actually did put in something like C of 3 and 2, okay, this would be great. Okay, okay, then I would get my values. Okay, and there's different ways of repping this actually, which could be more or less efficient. So this is a totally different form of vectorization that you may not have seen before, but it's extraordinarily useful. Okay, any quizzical thoughts? How do you find out whether a function is vectorized like this? There's only 2 ways: trial and error, okay, or reading the documentation. There's nothing that tells you that it works this way. Okay. Yeah.
It's really hard to see or kind of compare.
Sorry. You know,
you just walk through this vectorization thing that you were just doing.
There's a board that has to go up here, which would make it slightly easier.
Or you can do it on your computer.
I could do that, but there's no fun in that.
Moving up.
Oh, you want to? Oh, so you're cutting off half my board. I could do it. Have you seen my handwriting? Yeah. So basically, what we're talking about is just this. I mean, I believe it's already in the notes that I popped up there somewhere. If you go down a little bit on the days, it's in here. So it's basically this guy here, and this is what we're talking about here. Okay. And as you basically say, this is how many observations I want, and here's the vector of means, and here's the vector of standard deviations. And these either the recycling rule will come into effect, or not. But basically, we're just specifying this is a vector, this is a vector, and our norm knows what to do, and our exponential, our Cauchy, all these guys basically know what's going on. So this is the way to get around. This is the sort of vectorization that you really want to exploit because it's super fast. But as I mentioned, and as I mentioned again, there are these other things. When your functions are not vectorized, now is when you actually need to understand the applied family of functions. How many of you know what fapply does? So the rest of you don't. Okay. How many of you know what the lapply function does? Okay. So good. Okay. So these are entertaining. There's a list of these as well. We can talk about them. There's basically we use these all the time. We try to avoid for loops. They're almost as fast as the lapply, but boy, they're a lot less elegant. We can reason a lot about them as well. For loops, really useful when the second iteration depends on the value of the first iteration, and the third iteration depends on the previous two values and so forth. Okay, you just can't get around doing anything without a loop in that case. So use loops in those cases. But lapply is our friend, okay? Lapply, it takes this, it takes in some vector, and it's defined as this. I'll actually write it all out. Okay, that's its definition. That's the signature of this of lapply. What's it do? It basically takes in a vector, i.e. an integer vector, numeric vector, character vector, logical vector, or a list. They're all vectors, ordered collection. And what does it do? It basically does the following. Here's the thing you gave it. It immediately creates a new list. This is the input, this is X. Okay, so this is your input, and this is your output. lapply is just defined to do this. There is an element for each corresponding input element, and what we actually get is, what goes in here is fun of X square bracket I. Okay, the ith element of the output. Okay, so let's just take this guy. This guy here takes this guy as an input, and it calls fun. This is a parameter, so we have to give it a real function. Okay, it calls whatever we gave it, fun, with X square bracket I. Okay, so it does the loop for us. It's very fast, you know, but it's not the, okay, and it calls this. Oh, and by the way, it's going to do one other thing. That's all it does. You can't see this when I type lapply. You won't see it in here. I think this is a type. Okay. So what you're actually seeing here in this case is that we go off into this magic thing called an internal. There's these things called .internals and .primitives, and that's no longer R code. That's C code. Okay, you can't see, but what it's doing is it's looping over this. The fact that it's in C code makes it slightly faster so that life is good, but that's all it's doing. Okay, so it's calling the function you gave it with that the ith argument, and then any additional arguments you give. Okay, when it comes to writing functions, which we'll talk about soon. Okay, this is the signature of this. Of the lapply function. These are the parameters. Remember, anything that isn't matched by named X or fun, or that doesn't end up in assigned to X or fun in the parameters, when we do the argument matching, will end up in ... And in this case, the only thing R does with the ... is pick it up and hand it straight to your function. Okay, unaltered. Okay, so this is a way of being able to pass down extra information. So let's suppose I have these vectors. Okay, how do I get the min and the max of these? One thing I could do is I could unlist them all and get the max. Okay, but that's the max of the maximum. Okay, it's not the maximum of each vector. I want 3 numbers, which is the maximum of this. So what do? I do lapply over this list with 3 elements, each with different lengths. Okay, and then I just type down max. Okay, that's my function. When I call this function, what's happening? This gets matched to this. It's got 3 elements, so I'm going to end up with a list with 3 elements. This max function gets mapped to fun. So then when I call fun of X square bracket 1, that's this guy. Oh, and by the way, we often want to do this. We put in na.rm equals true. Okay, and this is weird. Okay, this is an argument to lapply, but it gets matched to ... and lapply doesn't look in ... couldn't care less. Okay, so but what it does do is it passes it directly on to each call to fun, which is max, who understands this, and it uses it. Okay. Is that clear? It's a little weird, but it's actually convenient. Okay.
So these 3 vectors could be the data frame, right? They would know to go through the calls? Or do you give it
nope.
a combination?
This is a list of 3 things. Could it be in a data frame?
The difference with the list.
It is.
Properties,
Special properties. What is that property?
that you can have different types of lists.
That's not the essential property. That's the list. The essential property of the data frame that makes it different from the list is, pardon? Two-dimensional, which is, somebody else said something, which is every element has to have the same length or else it's out there. Okay, okay, so that's just, so this these three, so I've drawn them this way. I could easily have drawn them this way, which would have been perfectly reasonable. Okay, they're an ordered collection, you know, whether we go horizontal. But in these guys, either way, they can't be a data frame because they're not the same length, but they are a list. But if I do happen to have a data frame, no problem whatsoever. I do this all the time. Okay, back over here. I mean, so I do this all the time. Okay, so I say L-apply over my favorite data frame. Okay, and I say class. Remember, we talked about attributes. Everything has a class. Everything has a type of. Everything has a length. Everything has names or null. Okay, I want to explore all these guys. These are what I do. I pick up a data set. All I do is I start playing with this. And when I say data set, vector, collection of, you know, distributed, you know, sort of non-combined things. Vectors. I'm always looking to see what I have. I interrogate it. I use the str function, but I'm always walking around like this. So that's great. So no problem. This works on a list. Vector. What is each element? The column of a vector. Okay, no problem. Now, what if I do this? It actually works. In general, it will not. Okay, it'll laugh at you because in general, your data frame or your list may actually have non-integer or non-numeric values. So calling the max of this, and it says, what's the max of California? And you go like, I have no idea what you're talking about. Okay, so if these are not integer or numeric values, so I tend to look at this. So the first thing I do is I say, hey, what's the class? Okay, so I almost never do the L-apply of that. I always start off with this, which introduces, I have to explain this too, okay? But that's what I do. I say, hey, look, these are all numeric. I nearly always do S-apply class and then do a table. I go, good, they're all the same. Good. Well, there's only one that's weird, okay? And then I go off and I say, okay, tell me which one. Now, okay, so we can do all of this stuff and we can pass down extra arguments. And by the way, just for fun, okay? So these guys, none of these guys actually have missing values, so it's particularly uninteresting, okay? But you could have done this. Going back to that example over there, I could have done L-apply on empty cars, let's say. And I'm going to say, I now say compute the max, and this is what we did over there. And then Rn equals true. Okay, that's fine. I could do that. I get the answers. But I could also do this. This is just a much, if you're confused by the fact that the na.rn is an argument to L-apply, which L-apply completely ignores, but does pass on, which is slightly weird. If that confuses you, you're more than welcome to do a little bit more typing and type x of this. You can always change. You can always change this. I have now written a function. Okay. It's got no name. It's an anonymous function because we're going to throw it away later on after this because it's just too easy to write. Okay, and basically it's just going to say if all it does, it takes in each. This is my fun over here. It accepts something. Okay, it better accept some input. What's the input? It's going to get called 3 times. Well, in my case, it's going to get called 11 times with each vector that's in the data frame. Okay, that's going to be the x. And it just, now it says, okay, now call max with that value. Oh, and by the way, add these arguments. This is just, these two are identical. They're just a much longer way of writing the same thing. Okay, everyone happy? Yeah.
I'm still a little confused on the difference between specify and
You haven't got there yet. You should be. Okay, so I haven't got there. So saying, okay, got all this. All we're doing is looping over these things. We do, as I mentioned before, most languages don't just have a for loop and you're fine. We do everything we're always working on groups of observations. We're working on blocks. And that's why the vectorized language works so well, because we want to operate on all elements in the same way. This is when you do not have a vectorized function. You basically have to write it yourself to actually do the looping over each element of the group that you want. That's what the apply functions do. And we have various apply functions, okay? And the L-apply is probably the simplest, the most generic. You can do it, as I say, anything you can do with a vector, you can do with, the list also works the integer, the integer characters, numerics, they're special cases to some extent. They have similar values, similar type of values. But this is the key idea, is that we're looping over things, we're passing in extra arguments. Great. Danielle, you had something you wanted to say?
So just to clarify, when you said LFI did a bunch of empty cars on the max, if there was a column that happened to be a string, would the whole thing fail, or would you just get a null for that one?
Well, the first thing to do is, again, I'm just gonna, you experiment. If you don't understand what R is going to do, try it and see. Design an experiment to verify what it is. Sometimes you can design a very bad experiment, which actually gives you a special case, and you go, oh, that must be the general rule, and you walk off with a totally misunderstanding of something very fundamental. But all we do is this: empty cars, Danielle, equals ABC. If I type this, what will happen? Why? It's not the same length. There's 32 elements in the empty cars, 32 rows. Okay, so you have to know that this, I mean, R is being very generous here. This is probably not a good idea, actually, to some extent. Oh, sure, everyone gets the same value, so it kind of works. But there is the recycling rule going on here, okay? And that's fine. So what is the class? So we go back out, and again, this is just, even when you're not trying to understand R, but you're just trying to make sure your code is correct, stop, check, did it do the right thing? Okay? Okay, we're lucky it did, because it could easily have turned that into what's called a factor. Okay, it didn't, but you really want to check, because they're very different, but they look the same. Okay, but again, so just check it. I mean, honestly, I cannot tell, I do this all the time. Okay, I do know this language very well, and it's like, nope, I do not trust that I remember all the rules when I'm focusing entirely on something else. I'm trying to do data analysis, and I'm now trying to ignore R. I need to check that R is doing what I think it's done. Okay, so this is fine. So now we go back and we do our this guy. Okay. What the heck did it do there? Okay, so it actually managed to give us back something. Why? I do not know. Okay. Okay. That's a bit odd in my okay. Okay. So we'll just, I'm skipping ahead because I kind of want to get a bunch of stuff out so that you can think about it and ask me questions after, after an hour. You go, hang on a second, Penny just dropped. That doesn't make sense. Okay. One of the things we can do is this. And this is where, I remember I told you we could do it this way, okay, where I basically do, here's your function, by the way, here are all the extra arguments that are fixed. These are constant. These are variables across each call. The only thing that changes across each call to max is which column I'm passing in, okay, but sometimes when I told you the same thing, if I wrote it this way, I know it's in here somewhere. Oh, come on. Okay, I'll just write it myself. Okay. I told you it was like this, max of that guy of X. Okay, I said that was equivalent. Everyone agree? Here I'm just being very explicit about it. I'm typing the whole thing out. Well, this is a useful thing, okay? Yeah. Look, I've got these 12 columns. One of them just may go nuts, okay? One of them, this might be, I don't know, I may have, instead of columns, I may have a simple vector of URLs, and I want to go and download each URL. Okay, and they all go to different websites. One of the websites may be down. Okay, all right. Okay, but what I want to do is I want to continue on if that one fails. I do not want them all to fail. Okay, so this is where, well, what you do is you actually can't write it the previous way I wrote. You write your own little function because you actually are customizing it now to say, try this, please. But whatever you do, if you get an error, just tell me about it and pretend we didn't. Okay. We will all know there was an error. It's discoverable later on. We can ask later on which one of you had an error, but do not actually terminate the entire computation. Okay, so this try function is very, very useful. So that's what will actually happen. Okay, this is if we really want to go forward and sort of say, look, I don't care if you fail, but just tell me about it. Then we can do that. Alternatively, what we could do is, what I would typically do is, if I really wanted to do that computation over all the columns, what I would do the following. I would do empty cars. So that's one thing. Let's do this again. Okay, so this gives me back exactly the right answer. Okay, so I'll show you in a moment where later on what happens when it gives the wrong answer. But what I would actually do is this. I would say max but okay, blah, blah, blah. What I would do is this, sapply of mtcars such that is.numeric. Okay? That's the same thing. And so in this case, I'm saying, now you got all these other things that I just don't really care about or could go wrong. I want to actually subset, I want to actually restrict my computation to looping over only the columns which are numeric. Okay? So what's this do? It says, go subset the column, because remember, this is a list, so I only need one dimension. Okay, I can put in two if I want, but it doesn't matter. Okay, this is a list, so it identifies these guys. Is.numeric, it says true or false, depending on whether it's a logical or whether it's a numeric vector. And if you type this will do its thing, and I won't get the last one back. But when you do this is what you do, okay? You don't write that until you're totally comfortable writing this. Until you're comfortable writing 4 or 5 lines of our code as one command that spans, let's say, 70 columns for the width of your editor. That's 350 characters. When you're comfortable writing that stuff, go ahead. The rest of the time, break it down into little pieces. Okay. So what you do is you go off and say, hey, let's break it down into the very smallest pieces. Let's do that. This is what I get back. Okay. Does this make sense? These are the fundamentals, as I say, the primitives. Because we talked about logical vectors. We got a logical vector. We've even got the names here. Now, we got the trues and the falses. Okay, that one's false. This is in this case. So now I know that by subset empty cars, I only get the ones for which this is true, and therefore it'll drop this guy out. That's great. And now I can even go further than this. I can break this down and say, okay, let's call that W. Okay, now let's call this empty cars of W is equal to temp. Great, life is good. And now what's temp? What's the dimension of temp? It's now 32 by 11. Okay, that's what I expected. And now I can do my lapply over temp with my max. And that is the same thing as we did up here in one go. Okay, but there's no need for it to be in one go. Okay, it's hard. It's cognitively challenging to go, what the heck's happening? Okay, yep.
So if we have a very large data frame, what makes more sense? Like we subset it first and then pass the argument, or we take the inner argument and
then subset the result.
do the checking inside of the function.
It kind of depends, okay? It depends. In this case, it's not going to be too bad, because when we subset, what's going to actually happen, again, this is, if you don't, understand this as your mileage may vary, okay, how useful it is. When we subset this is what's going to happen. This here, this command up here, okay, is called a square bracket. So it has to then go off and find square bracket, and then has to find empty cars and W. When it gets in there, it actually then will construct a new data frame. So we had 12, and now it actually constructs a new data frame, which is a list with 11 elements now, okay? And it will make a copy of each of the columns, but it won't. Remember I said of this copy on write business? It won't make a copy of those columns until somebody mucks with them. Okay, so in this case, it's going to be quite cheap to make a subset of this. So if you've got 10,000 columns and 10% of them are numeric, we're only then going to loop over. We're only going to apply this maximum to 10% of the columns, and we're going to incur almost no overhead in actually making the copy of the subset of the data frame. However, if you're, and if you think about this, if your function isn't just the max, but it says go in and change every value greater than 10 to be 0, now you're copying every single one. So now all 10,000 columns will actually be modified, and you still only care about the 10% at the end. That's very bad news. Okay, so in many regards, you're better off subsetting here in this particular case, but it really depends what you're going to do. But this seems generically that it's probably the right thing to do because you're not making copies. Okay, but this is where you have to think. Okay, and profiling also helps you. Yep.
Do you have a statement for
no. Try basically says just try it, and if you fail, thanks. At least you did your best. There's another function.
It'll print the fail.
It will print the fail. It will also, but most importantly, it will actually come back. The answer will actually be an object that has class try error. And we can actually say, are you one of these try errors? And if it is a try error, not only will it will actually contain an error message inside there. So we can go and actually take a look and differentiate between. We can do an sapply over the result and say which ones were failures, and then we drop those guys out. Or maybe we go back and do them again. But the try-catch function, there's two functions. Try, again, it's very useful to say, look, so it's really annoying. You go like, okay, written all my code, tested it on all of my silly, simple examples. Okay, now I go, I'm ready to run. I'm going away for a long weekend. I started on Friday morning. I come back on Monday and got to the first iteration and stopped. Okay? That's really good to actually say, no, let it run the whole way through. Okay? Put a try anywhere and let's look at the failures, and then hopefully there's only a small percentage that fail, and then we'll loop over those again. Okay? So the try is good. The try catch, though, is actually does allow you to say, for different types of errors, I'm going to allow you to handle them in different ways. So, for example, in some cases, there's a website that's down. Okay, I'm going to wait 10 seconds. Okay, and then I'll try it again. Okay, or I'll try an alternative website. So this is using HTTPS. I'll try to use HTTP or vice versa. Or I actually know an alternative website. And so there's different ways of handling different errors that allow you essentially to maybe resurrect the command. Okay, so that's the try catch function. Okay, so lapply. Everyone got lapply? So what's sapply?
Well, I mean, you used it. So
I used it, yeah, but that doesn't define it. The trouble is you can't define something by just 2 or 3 uses and go, oh, look, it always seems to give the same thing.
So it seems to be returning one, like it's operating over a set of lists or something, of vectors.
I'll just prove it to you. Okay. Here's sapply. This one actually you can read. It's not in C code. What does it do? It goes off and does its thing. Don't worry about how it does it. But what does it actually do? The key thing is it actually calls lapply. So what's the S in sapply stand for? Lapply is
Simplify.
okay. The S in sapply stands for simplify. The L in lapply stands for list. Okay, and that's because vectors and lists are the same thing. Okay, it could be vapply, but we use that for something else, so don't use V. Okay, vapply came after lapply. The sapply says simplify, and all it tries to do, and it actually tries to call this simplify to array function at the end. And here's the rule of thumb, okay? And this, we use sapply all the time. I use it here. I showed you basically, like, go find everyone that's numeric. Okay. Now, what if I actually do this? Let's go back over and do this again. Hopefully, this is helpful for you to reason about. That's lapply over mtcars is .numeric. As I told you, that is guaranteed to give you a list. Okay, lapply gives you a list back. End of story. Okay, even if you pass it in an integer vector, you get back a list with the same length as the vector, no problem. Now, remember what I said earlier on this? Almost the first thing we talked about. I said if you type that in and actually say, if you now use that to subset. Hold on. I was talking about the double square bracket, but let's try this one. Okay, now let's just try mtcars of that guy. Okay. Empty card. So we have a list, and we're subsetting by a list. Now, each of whose element is logical. What should happen there? It just doesn't make sense. Okay, but this makes sense. Let's go back and do this. That's my W. Okay. That's a list. And it's just not in the right form. Everything I told you about subsetting was about we subset by position, negative position, logical vector. I never said anything about a list whose elements were logical vectors. Miraculously, all of length 1. Okay? You and I look at this. You and I look at that and say, it's obvious. Look, that's just a vector, isn't it? But to R, it's not. Without looking through it, any one of these could actually have 2 elements, in which case now any subsetting would be nuts. Okay? So what we actually want to do is this. We want to collapse the result of the lapply is .numeric to a vector that looks like this. Because now I've told you that vector that we can easily do mtcars of that guy. Okay, and that's just no problem. That's the definition. These are all the rules we actually talked about last Thursday for subsetting. I told you. And again, I really mean this. If you understand those rules, the reasoning becomes trivial. And we've already said we didn't have a rule for this. And we can't. And the reason we can't have a rule is because R would have to look at that list go through and find everything. Well, hang on a second. What if that list? What if the list here that we're trying to subset, actually the first element is true, the second element is false. And it goes all the way to the end and it goes, oh, this is looking good, looking good, looking good. And the next one is ABC. What should it do? Now we're mixing subsetting. It'd be trues and ABC. Or what if, even worse, if one of them is true, 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 is 1, 1, 0, 1, minus 2. Or, okay, oh my God, I've mixed negative numbers with positive numbers. Now I can't do that either. So R would actually have to look at this, all the elements here and then use some heuristic that says, you all look okay. Okay? That's not good enough. Okay? We need a rule for this, and that's why it bails out when it says, this is a list. I'm not subsetting here. Whereas this, when we actually unlisted it, it was fine. So how does this relate to sapply? There we go. I got exactly what I wanted. With the same thing with lapply with an unlist. But this is all done in one operation. sapply is even smarter than that. Okay? Okay, so it's going to actually do something that we may not want to do. Yes. No problem. Simplify. Okay. So lapply for list, sapply for simplify that. Whatever lapply did, it literally is call lapply and try to simplify the result. And if you can't, just give me back what lapply gave you. And if you can simplify it, then I know what I'm going to get back. No, I don't. It depends. Okay. And then there's all these other things. There's a thing called apply, which is for looping over the elements, not of a list, but of an environment. You rarely want to do that. There's vapply, which is very much like sapply, but it says, oh, by the way, and I'm going to tell you what the return type is for each call. And if it isn't, tell me about it, it's an error. Okay, and then there's tapply. Does anyone know what T stands for in tapply? Table apply, because we do a group by, and then we do an apply to each of the subgroups. Okay, so there's these different apply functions, and and then what? So there's a function called apply. Hang on a second, it doesn't have any prefixes. What does the A stand for? That doesn't work. Okay. So what does the apply do? What's the apply do? No.
It loops over either rows or columns, depending on what you tell it.
It loops over rows or columns or more, or 3 dimensions, 4, 5, 7, 8, 10 million dimensions. It's a general purpose, and it doesn't work on a data frame. You're close, very close. I'm just giving you a hard time. It doesn't work on a data frame. It's really, really annoying. It takes your data frame and goes, hey, thank you, I know what to do. I'm making it a matrix. So it works on a matrix. And that's really bad news. If you remember, if you think about what I told you about data frames and matrices, data frames have columns that are potentially of different types. When you sort of naively pass your data frame to something that thinks it's a matrix and makes it a matrix, it starts throwing away a lot of information. Or worse still, it says, look at all those beautiful numbers and look at that one character of strings. Everything becomes a string, and now I take the inverse of this matrix, and it goes, I don't think so. Okay, so in that case, things can go very wrong. So I told you before, and I've written it, most of what I'm telling you, almost everything I'm telling you is written down. Matrices are very, very rarely encountered in data analysis. They're encountered in linear algebra, which we use a lot of in data analysis, but typically in functions that hide this from us. We do things like model matrix, which sometimes we do pick up and reuse, but in general, we don't see matrices very often. So, and when you take a data frame and turn it into a matrix, very bad things can happen. Okay. A lot of the time you don't care, but one thing I will guarantee you is when you take a data frame and you turn it into a matrix, you are making a full-on copy of every value in there. So if you've got a very large data frame, you're in trouble. Okay, and that's a given. The second it turns in, it has to copy it because the structure is totally different. So what does sapply do? Calls lapply, and then it tries to simplify. If every element, so basically we get back a value. This is the answer. This is the answer from lapply. Now the next thing is what does sapply do? It calls simplify to array. Okay. So what does simplify to array do? You can look up the documentation. It looks at every element here and says, first of all, do you all have the same length? And if it does, it says, okay, so far so good. And then it says, are you all compatible with each other? So if this is a number, and this is a string, and this is a logical, and this is a number, and this is a string, it says, yes, I can make you all strings, character vectors, and it will collapse this down to a character vector. Okay, if this is a number and this is a string and this is a logical value and this is a list, it goes, I'm out of here. I cannot simplify this without losing information. Okay, if it says, if this is a logical value, this is a numeric value, and this is a null, it basically says I'm in trouble here too, because I can't have something that has 0 length in a vector, because it wouldn't be there. So therefore, I would collapse this down by 1. And now you wouldn't know how to match them up to the inputs, okay? So it can't do certain simplifications. Now this works out fine. So these guys, which are they all return true or false. Are you a numeric or not? Yes, no, okay. There's really no other option, okay? So I get, everything's of length 1, so that's fine. And they're all actually logical, so I can actually, it will simplify this down to a logical vector. Okay, that's what sapply does. It will sort of say, if you're a logical and you're an integer and you're an integer and you're a logical, well, all I need to do is actually go to integer values, because I don't need to go up to numerics, because nobody needs to go. So this is essentially what it does, is it calls C, the concatenation operator, on all of the values here and gives you the answer. Okay, so that's fine. So let me just do this. Sapply on this guy, and let's do a function. Well, again, I don't want to write a function if I can possibly avoid it. There's a function called range, which will give me back the min and the max. I could write a function that gives me back a vector, which has the min and the max. But hey, somebody else wrote it for me, so I'm lazy. Okay, so now I just do this. Oh God. Oh God. That's what we've done. That's what happened here. Okay, so this is an example of what's happening. Okay, let me just do one other thing. Okay, let's get rid of number 12. That's Danielle's field, okay? Okay, now I get 2 different answers. One is here, I'm subsetting. I'm removing the ABC or Danielle that I put in, okay? So what am I getting back here? Both cases tell us, they show how sapply is behaving itself. What's coming back is, when I call this, I'm getting back a vector of length 2. Right, well, let me just do one other thing just to show you. Each one has 2. Notice, by the way, they're kind of, this goes down, this goes across, okay? For me, empty cars always sapply always ends up the wrong way, okay, when I get back a matrix. This is how I introduced a matrix. That is actually a matrix. Okay, so life is good. I told you matrices never arise. We're not doing linear algebra here. There's no linear algebra. This is just a storage mechanism, okay? It's just a convenient storage mechanism. The range gives me back a numeric vector, okay? So fine, I get a numeric vector here, a numeric vector here, a numeric vector here. They're all the same length. That was I said they didn't have to have all the same length, and they all have to be 1 element big. It's just they all have to have the same length. Well, then I can just basically combine them as columns. Instead of C, I can use C bind for column bind, okay? And that makes sense. Now, in here, these are numeric. That could well be an integer vector, okay? It's not, because they all started off as being numeric, so nobody bothered to actually figure this out. But if some of them were, I mean, some of these things like gear and carburetor, how many of you have ever driven a car with 3.5 gears? That was designed to have 3.5 gears, as opposed to it just happened over the years to end up with 3.5 gears. Okay, so these should be integers, and some of them should actually be, this is automatic or not. That should be a categorical variable, in which case we shouldn't be taking the range of it anyway. But these are all compatible with each other, so that's fine. So it just leaves them all as numeric, and that's what sapply does. And that was what this guy did. But in this case, this was numeric, 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 numeric. But up here, this was numeric, 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 string. That means everybody has to become character, okay? Because that's what we talked about with this hierarchy earlier. See, we're building on the primitives, okay? And again, if you understand this, why does this happen? Oh, okay, because that thing is in there, okay? So that's what sapply does, and this is how you get a matrix back in.
So if you do the same thing with LFI, then you're not going to get all characters back.
So this is what we got back with. That's what we got back with LFI when I actually killed off that column. So now let's put it back in again. And no, because no one's going to try to actually alter these. There's no need for anybody to try to play with these and make them compatible with each other. Okay. So this is these guys just hang out by themselves. Now the next line in sapply says simplify to array, and now it says, okay, I'll do my best. You asked me to. So here's a general rule of thumb: when I'm typing interactively and I know what I'm doing, and I know what the answer is going to be, I use sapply because it's a heck of a lot easier than unlisting. If I unlist this, oh my God, I get a beast. Okay, you know, if I go back over here, so now I just type unlist. Hang on a second, you know, is that the order in which I expected them? Maybe, maybe not. Okay, this is the, you know, am I going row-wise or column-wise? I may not want this, okay? So, so in some cases, the sapply, when I know what's happening, when I'm writing a function, especially if I'm writing a function that takes an arbitrary fun, and I have no idea what the sapply is going to do, then I call lapply, okay? Because I need it to be a list, because sometimes it'll be a list, but literally just because the contents change, not the structure, but the contents change, even potentially a value change. Instead of being 100, it becomes 101, and that magically kicks in something that gives me back something like 3 rather than 2. But in another column, I only get 2 answers back, then I would end up with a list. Whereas if it's 100 or less, I end up with 2, and I get back a matrix. I have to be very defensive about how I program on the result. I have to check, are you a matrix? What dimension are you? Or are you a list? In which case I do something else. So when we're writing functions that are going to be slightly more generic, then we probably want to use lapply. Or, as I mentioned, if there's a function called vapply that says, look, this comes back as an integer value or a logical value, or whichever, just, you know, whatever it is, I say it's going to come back as one of those. And if it doesn't, it's an error. Okay, and that's a good thing to use. So vapply is much more protective, if you will. It's declaring what you expect to come back from each call to fun. And if it doesn't, you get an error, and that's a good thing. By the way, when I have a colleague who goes, whenever, it was, 15 years ago, she would go, whenever there was an error, it's like, oh, it's trivial. It's like, I just mistyped something. Oh, it's like, it's the end of the world. It's like, no, it's really not. Errors are really, 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 really good, because they're much worse to have, here's an answer. It makes absolutely no sense. Go ahead and publish it. Really, go ahead and publish it. I dare you. Okay, answers that are close but not quite. Especially when you get significance, but they're not actually significant. Everyone else says, I can't reproduce that. That's not good. So errors are good, but that's why you want to actually inject them in. But defensive programming against some of this is good. So is everyone clear about sapply? So sapply is really useful for interactive use, okay? But be careful of it otherwise. Why don't we take a break and come back in 10 minutes? Here's one.
Because I know some of your doing assignments use the equal sign, whereas we're always supposed to use the against arrow. I'm wondering if you always just use the equal sign.
Okay, so there's a lot of this stuff I actually wrote down in notes, and they're sort of lying around the place. I'm not sure I put links to every single one of them, so if you can't find it, please help me by telling me there's not a link to it. Yeah, I nearly always use equals, okay? X equals 1, and there's a reason for that, is because it's less typing. Okay, the other one you actually have to put a less than and a minus. Okay, they're essentially equivalent. Okay, there's no big deal between them. This is the recommended way. I've never been one to follow rules, so I tend to do this way. This was introduced in the S4 language. This one's been going on forever. Okay, dates way back. This has finally been removed. It used to be that you would say X. You could say this or X underscore 1. Okay, used to be that that was the assignment operator in S and in R earlier on. The reason for this, again, just anecdotally, is because back in the early 70s in Bell Labs, there were keyboards that attached to terminals, really old stuff, and that character and this symbol actually gave you the same character code when you actually pressed it. The computer received the same digital signal. Okay, so they were one and the same. So they introduced this into the language, then they got rid of the terminals, and now all of a sudden these two things are still there. There is, okay, so we finally got rid of this, but I'm just illustrating just how arbitrary some of these things are. There is also this. How many of you know about that assignment operator? Okay, and now I argue that this is a complete joke at this point. There's only one person. I can look at a piece of code, and if I ever see that, and if I see it on 2 lines of code, I can tell you who wrote the code. Okay, it's a chap in Colorado, in NCAR in Colorado. Okay, And basically, this is used, oftentimes what happened is when we have these really dumb terminals, and I'm not this old, okay? But, you know, people used to be on 300 baud modems, okay? Really, really slow connections, where every character was painful. You hit a character and it may come up or not, so then you'd hit it again because you didn't think it would come up, and then it comes up twice. Okay, and you go, oh, then I'll back it up. So nightmare, okay? So, but these are really dumb terminals. So you type your long command, and then you go, oh, I forgot to assign it to something. Now, you're used to just going back to the beginning of the line, Control A or whatever it is, bring the beginning of the line, you edit, then you jump to the end and finish it off and do all sorts of things. But you couldn't do that in the past. So therefore, this was your safety net to actually go, oh God, if I hit return, it's going to do something. So in fact, actually, you'll also find that people would just hit return and go, ah, screw it, I'll do it again, okay? And it took a long time, okay, because these were very slow computers. So that's also why you'll see this thing called .last.value. Have you come across this? Okay, so when you issue a command over here, I'm getting all answer the equal sign. But when you do this, when you say 1 through 10, you go, okay, so suppose that took half an hour. And you go, I really should have assigned that to something. Well, let's just go .last.value. Okay, and I'll call that Bob. And there's Bob. Okay, so when you forgot to assign it, R automatically squirrels it away. Now, the next time around, it'll overwrite .last.value. It'll always be the value of the last successful command. Okay, so this is another way of doing this. Okay, so this is the history of this stuff. Now, okay, so here is your quiz for the day. What is the difference between plot x, y, main equals this, and plot x comma y, exactly the same thing, main gets thing. What is the answer? What's the difference?
Second, you're trying to tell it to create an object from main, which you're assigning something to, as opposed to setting a parameter.
Exactly. So this is setting the parameter named main to this value. Okay, we're doing argument matching. Okay, remember? So you have the call, you have the function match.call. If you don't want to think about, if you want to cheat in this quiz, just type these two into match.call kind of idea and find out what it gives you. Okay, but we can also reason about everything that we've talked about. This guy here, okay, so I'm using equals. Now this guy here will not create the variable name and assign it to it. In this case, let's take this guy. At the end of this command, with reasonable certainty, and that's going to be one of the fun things. With reasonable certainty, main will be a new variable. I will do this at the command line, okay? It's even worse if I do it in a function, okay? But main will be a new variable with this value, yeah? What will be the parameter to which it is assigned in the call to plot?
Is name positional?
There's no name here, so it'll be an unnamed argument. These are all unnamed arguments. So matching the call will just now go and put these in order. So the main will go into the third argument for plot, which may or may not be ... Okay? This one will automatically, we will go through here and match by name. Does this exactly match a parameter name? No, because main isn't actually in there. Okay? So now we do partial matching. The partial matching doesn't match either, so it goes into ... because it is named. Okay, so this is a special case. I can come up with other examples, but that's fine. Okay, so do you see the difference? Here, this is an assignment, and this is part of the problem. If I do this, x gets 1, or if I do main gets this, so I do this at the prompt, and now I go, okay, now let's lift that code in and put it into a function. So I just cut and paste it back in and put it in here. This will be an assignment. This is main gets this character, okay? That's this guy. So I do this here, check it works. Now I do it in here, check it works. Life is fine. But if I had done main equals here and then cut and pasted it in exactly the same way, I'd get a totally different answer. Main would now be matching the title of my plot. It would not create the variable name. So these two are different when I insert them into a call. They're both identical by themselves. They're not when I put them into a call, because the equal sign means parameter name when it's inside a call, and here it means an assignment. Why would we? There is a book, a famous book on R, that actually does this in an example. It's on, I believe it's on the right-hand side page. There's a plot, there's some text, there's a big block of code, and there's some text. I can see the page, okay? And somebody pointed out to me and said, look, here's the stupidest thing I've ever seen written. Not quite, but close enough, okay? What if I do that? Why would I say that this command will nearly always result in a variable called main with a value that is this? Why is it the nearly always? You'd think it would happen, always. I'm saying, look, you'd think R would say, he's trying to assign this, he does that. Then the result of an assignment, by the way, we actually want to be able to do this, y is equal to 1. So when we do this assignment, the result of the return value from the assignment is the value I assigned. So then I can chain them together, okay? Because now I'm basically saying x equals 1. So that's fine. So this assignment basically returns this thing, puts it in. We have this issue with the named arguments or not, but suppose this is what we wanted. You could, if you wanted to, do this. Main equals main gets. Now, in this case, main is the name of the parameter. This is the name of the variable. That's the value of the variable. The value of this assignment gets put into here. Either way, it doesn't matter. Under what circumstances will main not, when I come back at the end of this command, when is it that main will not exist as a variable? 2 cases. When your computer explodes, okay, so nothing's there anymore. Okay, but aside from that odd scenario, when's the other one? I've told you everything you need to know.
There's an error.
No. Well, yes. If I get an error, okay. So if it looks at, okay, I'll give you a hint. If it looks at X and says, look, there's no way that you can give me a function as the value to plot, I'm out of here. Okay, or you've given me an environment and I know nothing what to do with. So then it doesn't even get to this. That answers your question. Okay, but there's a second case to it too. One is, but because this isn't evaluated before the call, it's lazily evaluated. Remember? Lazy evaluation. It says, I won't do anything to this until I need the value. That means it doesn't do the assignment. It just holds on to it and says, I will do this later on. So if you get an error, sure, we never actually finished. We never actually got to there. But now it depends. But if I have code that says, look, if X is a vector and Y is null, then I'm going to do this. And I'm never going to use the main. Then I never use the main, in which case, or I never use this third argument, should I say, then this assignment never gets done and it's lazy evaluation. Now, imagine if it says, I toss a coin to decide whether to ever use this third argument. So it actually looks at the contents of X and Y, not just the structure, but looks at the contents. You have no idea whether this is actually going to get evaluated. So in that case, this is nuts. So that's my argument for saying this is just fine, okay? Because you should never be putting this in calls. The only time that these two are different is when you lift this previous expression that worked and did an assignment, and you put it into a call, and now the meaning changes. This would avoid that meaning changing, but it's suicide. 99.99 to any decimal place you want, it will work. And when it doesn't, you will end up scratching your head for the rest of your life, okay, as to why it didn't behave. And then that's what you'll do is you'll go back and unpeel and do all the command. You'll unravel this long command and do them one at a time, and then it'll go, oh, I see. Eventually, I get it. Okay, so that's why they're slightly different. But to me, I like less typing. Okay, and literally the equal sign was put in because the less than minus is 2 characters, is 2 keystrokes, and the underscore is 2 keystrokes, and equals isn't. Okay, and that's why it sort of those of us who are lazy. Yep, somebody had a question? No? Yep.
There's a point in time where the reverse will happen, and you should have used the other ones.
Where you should have used the equals as opposed to the assign. If you didn't mean to assign it. I mean, if you genuinely didn't mean to create a new variable, but no, in general, people should know what they're doing. Okay. Now there is this other thing. So no, this one is always fine, except for when you use it in the middle of a call, you are playing with fire because you need to now understand the lazy evaluation, not the general principles, but whether or not that parameter will be evaluated or not. But no, this one will always be fine. This one is more convenient. And then there's this other one, by the way. Okay, which is two left hands and a minus. Okay, it's like really get it. Okay, this reads as X gets Y. Okay, and this is sort of like no, really it gets it. And this is a global assignment. Okay, this means not in the local environment. Okay, so that's a different ballgame. Remember? So that's essentially a global variable. Remember what I said about global variables?
Don't do that.
Okay, don't use them. Okay, I'll show you when you can use them. Okay, to good effect, but they're really, in general, we don't use them. And this causes untold chaos. This is quite similar to, I told you about the attach function. This is not unrelated to the attach, where you basically can end up with copies of variables in different places, and you think they're one and the same, but they're not. Okay, everyone happy?
Could you recap one thing? You mentioned using match.call to troubleshoot this, and when I was typing it, I'm getting a syntax error. Could you just recap how to use
I have no idea what your syntax error, but let's do the following. So we had a quote of plot of x comma y of main gets ABC. Okay, so remember, if I quote that, I'm saying don't evaluate it, just treat it as a piece of text. It's very similar to parsing this, but I've got it there. Okay, so I have that guy, and then if I say match.call on plot is my function that I wanted to do it against, and now I get the right thing. So you got a syntax error somewhere in here, which is different. So now that's before we get to match.call, it can't understand your command. Does that make sense as to what's happening? So, and again, building it up incrementally. So you sort of say, check this behaves, okay? Because if I have a typo in here, so if I go back over to this quote and I sort of basically take out this comma here, that says, I'm sorry, this is a syntax error, okay? I have never gotten to evaluate this guy, okay? But that's, and this isn't particularly exciting because it just basically does, but it does match X to X, Y to Y here. So I happen to be using very silly names here for X and Y because they match to the parameter names. But life is good there. But again, if I want to, I could just put in A and B. We get the match. And the problem with this is that's the definition of plot. It's extremely boring. But if I take a look at something like plot.default, okay, this has way more arguments, okay? And if I know that that's what's going to end up getting called, then you see my third argument would come in as type. Instead of the main, it would actually end up being type, and it would be in the wrong place, okay? And remember, well, you don't remember, the plot dot, you can't tell from here, but this plot.default will pick up the dots and pass them straight through. So the third argument in my call, in this call here where I do the assignment, this will actually turn out to be the third argument. So the type will actually turn out to be this string. That's supposed to be P for points. And if I now say it's ABC, it'll go, no idea what you're talking about, okay? Because I may have meant it to be May. Everyone happy? Just for the fun of it, actually, what's this? This is one of those tongue twisters and sort of brain and little, does this make sense? Apparently. Okay. So C, by the way, before I started this command, C was actually the concatenation function. There was nothing in my global environment called C. There is now, because I've assigned it into here. This C, remember, R is going to look at this. It's a call. It's an assignment. It's going to be a call to equals. So this is going to be equals with two arguments, C and this thing. Okay, if I parse it, it's call equals, two arguments, this. Okay, equals says, I couldn't care less about this. When equals is evaluated, it says, I do the thing on the right-hand side first. This is lazy evaluation. So it goes ahead and evaluates this. What's it doing? This is, again, do our call stack with these promises, environments. So it now looks for a function named C. We don't have one in our, so it walked the search path, find one in base. What's this guy? No, it's a name. It's a parameter name. Okay, this is a parameter name. This is a function. This is a parameter name. This is a symbol, which we have to look up. We don't know whether it's a function or not. And then what so this is basically saying, call the concatenation function. We construct a call frame. Lo and behold, I happen to have it here. It takes dot, 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 okay? And then this thing over here. So this basically says, this is going to be the function call C. This is going to be the function call C. This is going to be the name of a parameter which gets matched into dot, dot, dot. And this guy over here is going to be a variable in my global environment. Perfectly obvious. You're seeing the same word, the same name being used in 1, 2, 3, 4 different places. Okay, and they all make perfect sense, and they're all different. Except for those two are different only because I'm going to find C in the same place. But here I'm looking for a function, and here I'm looking for any variable called C. So if magically I had another variable called C somewhere in my search path, but that wasn't a function, this would be different from this, okay? If you understand that, which is not very complicated, but if you understand that, you've got it, okay? And if not, just think about it, okay? And think about how you would actually debug it, to actually wander through and actually find out what it's looking for. Okay, any other questions? Yeah.
Does it do partial name matching on this first C that didn't write it down?
Which that's it. Partial name matching, it will first of all do full name matching. So it's gonna, this is the function, this is the definition that it actually finds. It finds C, okay? And if you wanted to, I could just say debug a call to lowercase c, and we'd actually be in there and we'd see what goes on. I can also do match.call here with C as the thing I'm trying to match against, and this is the call. So it does full name matching. Do I see anything that is named C here? No. So now it does partial name matching. Does this match? No, it doesn't, okay? If I typed R in here, would it match this guy? Yes or no? You two fight it out. No, it wouldn't, because it's after dot, dot, dot. This is the gotcha with the after the dot, dot, dot. I need the full name or else it won't match. If this was recursive before here and this was R, I would match it by partial name. But full name matching, then partial name matching fails on both, so then it has to end up in dot, dot, dot. Okay? Because there is a dot, dot, dot. Happy?
So in the dot, dot, dot,
It'll be called C, and the value will be this. Okay, it won't be until I actually evaluate it. This will come in lazily as being, I'm looking for the symbol C. Okay, but then we'll eventually evaluate it, and now I get back a list. Why didn't I get back a vector? Because if I do this, if I've done C of 1 and D equals 2, I get back a vector. Why did I get back a list? And I know it's a list because I have a dollar sign here telling me the elements. Or because I can say, are you a list, please? Pardon?
Because you can't have a vector.
Because I can't have a vector of function. So the C function is trying its hardest to get everything back to a vector, but it says there's some things that just cannot be vectors. Like a data frame is not a good idea to make into a vector, because now I'll lose all the information. I'll essentially concatenate all the elements, all the individual values together. A matrix, what about a matrix, which we haven't told you much about a matrix? It'll unravel those, because a matrix is a vector. A matrix is just a dumb old vector which has rows and columns. So it actually has this attribute on it that says it's the dimension. I'm going to tell you the dimensions. You're going to store the matrix by column, okay, down and up and down and up and down and up, okay? But it's really just going to be a big long vector. You can use it as a vector, but it'll print, because of this magic dimension that's attached to it as an attribute, it'll print the correct way. But when I concatenate a vector with a matrix, I'll get a vector. But this is where I probably want list in here. Okay, to actually say, no, keep this as a list because I'm in charge here. I'm not letting you do your little collapsing tricks that sometimes get me into trouble. Okay, any other questions? No, none, yes. Okay, so here's one. We've gone through a bunch of these things. We've kind of done this. Actually, let me just show you this. Just in the start, I was asking. Here's what I was doing with the try example. I do an lapply over a sum list or vector, and I want to call get.title, but some of them can fail because my code isn't robust. okay? And then literally this is what I do, is I write code and I go like, I couldn't care less if it fails, okay? I just fall over, I'll look at the ones that failed, and then I'll go back and adapt my code to make it handle those things. It's going to be very much incremental, sort of explorative code writing, because I cannot anticipate every situation ahead of time. So what do? I wrap it in a call to try. I keep it as an lapply, because sapply would try to collapse it down, and if all of these gave me back a string, then it would take my error. When it gets an error, it would actually try to make the string an error, which would be the error, which is fine, but it makes it slightly harder to find the errors again. So basically, I say lapply, and now what I can do is I can loop over all of the answers. This is a list. Loop over all of the elements of the answer and say, is you a try error? Okay, and this is a general function. Are you one of these classes, an instance of this class? Okay, so I can say is list, is thing, and again, this is, we talked about this with sapply. This is calling every element on that answer. We're passing it into a call to function. The function is with an extra argument called try error. This guy here doesn't apply to sapply. It's not an argument for sapply. It's an argument for this to be passed to this each call to is. Okay, everyone happy? And if you want to go down, as I say, there's this thing called try catch. So unfortunately, and this is something I'm going to get to, but I'm going to repeat it as many times as I can. When you are writing functions, and you should be putting in work. How many of you have been frustrated while reading an error message or a warning message from R? Finally, we now know all of you have hands. Okay, so it's slightly annoying when it goes like something, 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 entirely cryptic. Hang on a second. I didn't call this function, someone else did. Okay, I don't know what X is, and what on earth does this error message mean? So you should spend, your code should actually construct error messages, actually, by saying the dimension of this was, let me go get the dimensions and stick them together and say, it was supposed to be this, you gave me that, that's why they're incompatible. Oh, I see. I know why that one's got this dimension. That must be the X that came from 10 function calls earlier or something like that. That starts ringing bells. But in addition to which, when you're writing functions, and you're all writing functions, by the way. We wrote a function earlier today, which was just to pass in the na.rm. Okay, these anonymous functions, or when we just want to actually combine, little throwaway functions. We write functions all the time because they're so easy. But when you write a function for your, and you sort of say, well, look, I'm never going to write a code for anybody else. Yes, you are. You write code for yourself because you should be reusing your own functions. You're going to save a bunch of time. Okay, if nothing else, just so that it can be reproduced by yourself in 6 months. I know one person who was just getting ready for their defense of their thesis, and they went back to look at one of their early results and go like, that doesn't make sense after these years of experience. And then they found out that the theorem they were based on was wrong. Okay, that it was a preprint that had been retracted, and likewise, people who go like, oh, okay, now I'm going to collect all my early work, and you go and find out you cannot actually reproduce it. That's really bad news. Or if somebody says, I challenge that, and you say, well, all the code's gone. You need to be able to rewrite. You need to be able to rerun your own code, and that means it should be in a function, okay, to be reused. But one of the things you really should do, and R does not do enough of this itself because it came in afterwards, but you can actually put a class on every error. Okay, so in this case, the R curl package, which I wrote, actually is an example where I put time into it and says, look, I get an error. So you go and get a URL, and you get an error. The error message says, I couldn't connect to this host, okay, or I couldn't, or that page, you're forbidden access to that page. I would actually have to read the error message, okay, and that's not actually very useful because there's two reasons why it's not very useful. One is it's free-form text, and the other is it may be in a different language. Okay, I wrote the error message, but other people translate the error message, so at runtime it may be in a totally different language. So if I now try to say, oh, let's look at the error message to try to differentiate the cause, real trouble. So what we really want to do is we want to be able to say, okay, look, you got an error. It's really a generic curl error. Okay, this way of getting data off the web. Okay, it's generic, so it's different. I now know it's a problem getting a web request. But it's even more than this. I couldn't resolve the host, as opposed to you gave me the wrong password. This is a really good way of actually sort of saying, saying this type of error occurred as opposed to that type of error occurred. And it's very easy to construct these different types of errors. And so I'm really encouraging you to do it. You still get the error message. People still see exactly what you would, but you now can actually respond differently. Okay, you can use the try catch function. Okay, so instead of just try, you can actually use try catch to say, hey, let's go to the newyorktimes.org, which is not a web page. Okay, newyorktimes.org is, and nytime.com is, but this one finally isn't. And now we're basically saying, okay, couldn't resolve the host, then I want to go to New York Times. Okay, but otherwise it's an error, and I'm going to give a more explanatory message. What this allows you to do is actually to react to different types of errors in different ways and potentially salvage the results or report a different thing. And it's very, very easy for you to actually to write your code like this. So the try is really useful. The try catch is even more useful if you and other people actually differentiate the types of errors. Any questions on that? Again, throwing this out, hoping you'll think about it, and hoping you'll come back and ask me, how do I do that then? Okay, because it is the first thing to do is actually say it's worth the effort. And we've gone through a bunch of these different things, except for this, factors. Things that everyone hates in R, okay? So I'm just gonna, again, I've written some of this down, it's available other places, so let me just try to explain to you what they are. I think we've got logicals, integers, numeric, character vectors, we got lists, this is great. Any categorical variable, like what program, what grad program you're in, what degree you have, okay, blah, blah, blah. Okay, what grade you get, okay, what gender you are, what ethnicity you are. All of these things are categorical variables, okay, which are very different from real valued or integer valued variables. These do not map onto the number line. If you try to take the difference between Eskimo and Caucasian, it doesn't mean anything. And even if it does mean something and the difference is 2, it's certainly not 2 on the same number scale as the difference between, Hispanic and any other ethnicity. These are totally arbitrary numbers. We do tend to use arbitrary numbers for these. People code these as 0, 1, 2, 3, 4, 5, and they make it up, and you need to look up the code book. So categorical variables are sort of, they're intrinsic in R, just like missing values are. So we don't want to actually do things. We want to treat them specially. What you can do always is to actually use character strings to do this. And that's absolutely fine. So you just put labels on them, Hispanic, African American, and so forth. And this is a really good thing as opposed to 2. Okay, 2. Okay, and now you have to go and consult the code book. Okay, so this is also a place where putting names on them would be useful. Okay, so names are, we talked a little bit about subsetting and names and the names of the vectors. They're really, really useful. But there's also something I kind of want to basically be able to do with them. So character vectors are just fine to actually do all of this. And what we could actually do is the following. So we could actually sort of say, okay, so this is, you're in physics, okay, these are your programs. So we have a vector of somebody's in physics, the next person's in geography, the next person's in, so let's just call this PHY. The next person is also in physics, the next person's in statistics and so forth. We can do this as character strings, and we have unique values. Okay, it almost works until some idiot actually mistypes something, like they type physics instead of phys, okay, or instead of PHY or so forth. The point of a categorical variable is that there is a finite set of possible values. And that's it. You can only be in one of those values. So if somebody comes along and says, I'm in physics, you go, no, you can't be. There's no such thing as physics, that's an error. And I want to be able to signal that and to say, that is not a legitimate value that you can occupy. There is a finite set. And in other cases, I actually want to be able to say, you got an A plus, you got an A, you got an A minus, and so forth. When we actually look at these, we alphabetize them. Okay, so whatever it is, anthropology is better than zoology, because zoology is a Z. Okay, so that's arbitrary ordering. Here there is a natural ordering. When I plot them and when I do things with them, I actually want to see that ordering. So we actually introduce these things called factors. Okay, a factor, and then there's an ordered factor. And this actually gets to a little bit of class inheritance, if you will, which is different from the integers versus the numerics being in a hierarchy. What a factor is the categorical variable where we specify the set of all possible values, and then we actually get observations from that, okay? So when I look at this, so we can actually take a character vector and we just say factor of that, please. Okay, and what R does in this case is it goes through and gets all the unique values and says, these are all the possible values. And you go, not true. There's a bunch of other programs that we haven't observed. But for for the moment, for convenience, let's just assume this is the set of all possible values. And R will create a new variable, which is a factor. It looks like an integer vector. It looks like a numeric vector, okay? It's actually got a bunch of values. It's an ordered vector. The elements are in the order that you gave them because they should correspond to other variables when we measure things on the same observational unit. And we get this. Now, if I want to be good and helpful, I can actually say, oh, and by the way, the levels is equal to this. And I give it the entire collection of all possible values. Okay, so somehow I know this. So if I leave this out, we just go empirically based on what's in our sample. But if I happen to know, I can say, yes, you never saw anybody from zoology, but zoology is a legitimate value. That means if somebody comes along and tries to replace a value here, I got this guy wrong, he or she was in zoology, it will accept that. If I go and replace, if I don't specify the levels and I try to shove zoology in here, it should say, I don't think so. That's a missing value, or it's an error. It's not a legitimate value. So there's a constraint on these things. And this is very helpful, okay? That a character vector can't. I can put any crap in, okay? It's just a character vector. Here I'm telling it more, just like we said about an LM being a list of, a linear model being a list of things. No, it's more than a list. It's an actual, it's the result of a linear model. So the levels is a very useful thing to pass in. It's not obligatory, but we can actually do this. The key thing about factors is that, well, a lot of people hate them. When you do something like read.csv, okay, or read, which calls read.table, okay, you give it a file name that's tabular data, it reads it in. By default, when it sees a column that looks like strings, that don't look like numbers, it will make them into factors, which everybody hates. But they're actually really handy, okay? So there is a way to say, okay, strings as factors equals false. And you have to spell it all out fully, okay? So strings as factors equals false. And this says, when you see a column that you think is categorical, leave it as character vector. Okay, and a lot of people use this. Is that true? Have any of you typed this in? And how many of you haven't ever typed it in but still get character vectors back because you set it globally in your options? A lot of people set it in their options. You can actually, they're in R. In R, there is an options. There is an options vector that controls a lot of different things and can grow to actually control other things. You can shove options in as you want. There are all the options. So let's just take a look. Okay. So, okay, one more. Okay. Here are all the options. Some of these are mine that I look at: SOAP API key, Scopus key, and different things. But there's all these other ones. And one of them is strings as factors you can actually set. I don't believe I've set mine. Okay. So you can actually control a lot. This is very bad news to put code in your options, because no one knows. When you showed me your code, I look at, what, behaves differently for me. And you go, oh yeah, no, I have an option set. Well, you never told me that. Okay, so that's bad news. But you can turn off the factors with this, or you can turn on the factors with that. They're a very useful thing. But here, okay, so they give you a lot of constraints. They also allow you not to, in some cases, you may actually have 1, 2, 3, 4, and 5, and these are actual possible values. So you do this a lot in surveys, where you sort of say, how strongly do you feel about subject X? And they code it as 1, 2, 3, 4, or 5. These numbers really don't mean anything. They are categorical, and you shouldn't be treating them as the difference between this is the same as the difference between this. But people do it. So sometimes you actually want to tell R this is actually categorical. So you can do that too. So that's fine. So we end up with a vector, an ordered vector. How come I didn't mention these before? I told you had logicals, integers, numerics, character vectors, complex numbers too, which I told you don't show up very often. And then I told you had lists. So these are all vectors, okay? All ordered collections with different characteristics. Why didn't I mention factors as being in this thing? Because they are very, very important. It's because I can build factors out of the other ones, and we do, okay? A factor, if we actually, so let's just make a little factor. Okay, so here I have examples of this, but like, so I just do something, I'm going to sample the letters. So it's 26 letters, okay? I'm going to sample the 26 letters. I'm going to sample 20 of them. I'm going to say, I'm going to allow replacement to be true, okay? So this is X, okay? There's X. Let's do table of X. So there's a couple that came in twice. So it's clearly I'm not going to get all 26 letters. So again, this is a case where I know there should be 26 possible categories, but I only observe, whatever it is of them, however many unique values, 18 or so. Okay, so now if I do something like this, if I say factor of X, okay, so let's call this F1. There's F1. And you see it actually prints, there's no quotes around here. This is not a character vector. There's no quotes around them. And it also shows me the levels. And the levels are A, C, D, so I clearly missed B. I didn't get an E. If I wanted to with F2, okay, I could have done F2, or I sort of said, oh, by the way, trust me, the levels really are letters. Okay, now F2 says, oh, here's what you observed, exactly the same thing, but here's all the set of possible values you could have had. This is a good thing. Again, when I do a table on this, it'll actually tell me there were 0 Bs. So it's kind of nice when you're doing surveys and you just say, no, there was no Eskimos. Okay. But Eskimo was a legitimate category here, as opposed to, so you're telling everybody what the categories are. There are times when you want to drop these guys, when we actually have levels, and you go like, but I didn't observe any, so you actually don't want to call these levels around. We can do that too. Okay, so we actually get two different guys. Now, what's the class of F1? It's a factor. It's a categorical variable. What's the class? What's the type of? Again, you often want to look at the class and the type of. So what's the type of this? Who can type the fastest? It's an integer vector, and that's how we're building this.
Are these enums underneath? No.
Nah, we can't have enums. And okay, so the type of this is an integer vector. Okay, so let's take a look at the structure of this guy. Of F1 and F2, it doesn't matter, okay? Structure of F2. It's a factor with 26 levels, okay? Okay, 26 levels come from it, and these are the values. 20. What position in the alphabet is T? A, B, C. Okay, everybody sing it together. Okay, it's 20. I don't know. Okay. So we've got these guys. Okay. So what is this? Let me do this. What are the levels? I specified the levels when I created this guy, but it doesn't matter. I can use F1 if we want. Well, what are the levels of F1? Let's say this is the one where I didn't give it all 26 letters, just the ones that were observed. Here are the levels. Here are the levels of F2. Okay. I specify them, okay? What's this? Levels of F2 of F2. First of all, let me show you F2. Now, let me show you the levels of F2. This is the levels of F2. And I'm subsetting it by F2, too. Remember, F2 is an integer. Before I do this, let me just ask a question. What is the range of F2? Says, I have no idea. It's not meaningful for factors. How can you tell me what the min and the max are of A and Z? Okay, it doesn't make any sense. Well, okay, I want it to make sense for me because I want to act. So see, these things are automatically stopping you from being stupid. Okay, so let me just turn it into an integer. Okay, now it's 1 through 24. Okay, which actually surprises me. Why is it doing that? Okay. Yeah, that's fine. Okay, no problem. Okay, that's good. Okay, that's the point. Okay, I've got 26 letters. Okay, let me do it on F1. It's slightly different. Remember, F1, I said use the empirical data to define the levels, only what you observe. The other case I said, no, there's more that you didn't observe. There's 26 in F2, but I only got up to 24. Okay, I only got up to whatever it is, W or whatever it is. Okay, this one I only had 16. Okay, and I only got 16 values. Okay, but now, so the thing is, these are integers. So if I go back to that guy, this says, go take all 26 letters and then subset them by the values. And now remember, if I just look at F2, do they? T goes with T, O goes with O, N goes with N. These are all identical. The value, the integer value in a factor is the index into the level set. Okay? Who cares? Does anyone care? I'll tell you why you care. Okay, so let's say we've actually got colors. Okay, so if I got colors which are 26 different colors, okay, I got 100,000 letters or values from this categorical variable. I can use these to subset into another vector. So if I want to say plot x against y and color code based on this categorical variable, I just need to find the 26 colors I want to represent the different categories. And then I subset them by the factor itself because it's an index into the level set. Does this make sense? So these are set up to be convenient ways to index into other parallel vectors that parallel the level set. Okay, so oftentimes what we want to do is we want to plot a real valued number, a real valued vector against another real valued vector, okay, where these are pairs of observations, and we want to color code based on a categorical variable, and we want to choose the plotting character to be a plus or a minus or a question mark or whatever it is based on another categorical variable. And what we do is we just set up those colors and the plotting characters to be something with the same length as the number of levels, and then we just index by the factor itself because it's an integer vector. So it's just a convenience mechanism. And in the notes I gave you, you'll actually see you could actually do this by actually putting the names of the levels on the colors and then subsetting by name. But there's no need to do that. This is it's much more efficient once you learn this, that we're basically, unfortunately, if I do something like the following, which is, here are my colors that are red, green, and blue. Okay, and if I have a factor that looks more like A, B, C, and B again. Okay, so this is my factor, this is F3. Now colors of F3 gives me back A corresponds to red, so I get 2 reds, then followed by green, followed by 3 blues, followed by a green. Okay, and that's why factors are useful. Okay, and also to say because they will protect you against sticking strings which cannot be which cannot actually be valid observations, but they prohibit you from putting invalid observations into a factor because you basically prescribe the finite set, or like enums in C++. Everyone happy? Yep.
So if say the colors was just 2, would it recycle and give you red for C?
No. I've answered that question before, and I'm not saying you should know that. I'm saying let's try to piece back what would actually happen. What is actually going on is it's treating this as an integer vector. So we're going to get values. We're going to get values 1, 2, and 3. Okay, we're going to get value for this guy, for the factor. We're going to get value 1, 1, 2, 3, 3, 3, 2. So when I subset with that, what's going to happen? I'm going to ask for the third value of 2 colors. So what's that going to give me back?
Yeah.
Empty. So let's just try it. So first of all, let's just do this. So let's use all our subsetting facilities all in one go. Let's get rid of the third one. Okay. So rather than type it in again, so this now gets colors of -3 gives me red and green. And now when I subset that, I get back NAs because I'm asking for the third element of a 2-element vector. So it says that ain't going to happen. Okay. Happy? And so this is why we actually do need to end up with the right number of things to subset by for the to be the same length as the level set. Okay. By the way, let's just do something like let's take F2. Okay. There's what's the length of F2? Well, actually, let's just change F2 of 1 to be NA. So I'm now specifying that it is a missing value. Okay, I was wrong. It wasn't T. Okay. So now let's take a look at F2. Something that's important to recognize is it doesn't print NA. It prints less than, NA greater than, to indicate. So I mentioned that it doesn't show quotes. It also doesn't show NAs here because NA could be a valid level. Again, it's an acronym for Nebraska. So it would be perfectly valid. So we actually differentiate between a valid observation without the less than, greater than, or an actual missing value. Okay? Everyone happy? No other questions? Where else are we? Okay, there's factors. I mentioned matrices, and I mentioned that you never use them. How many of you do simulations? Okay, so simulations, it can be useful to use matrices. Also, when you're computing distances, that's also where they come up, although distance matrices, and we've used distance a lot for clustering and for machine learning in terms of support vector machines, and all sorts of things come down to distances. An awful lot of statistics is just the distance between things, i.e., you know, the between group distance and the within group distances and so forth. So distances are huge. They turn out not to be matrices very often, actually. They turn out to be things that look like matrices because you get a matrix and we only really compute the bottom part because they're symmetric. So why bother computing the other part? We could fill them in. Oftentimes we represent them as very small subsets. Okay, and so they can be slightly irritating. But here's the thing with matrices: they behave just like data frames. So if you have a data frame that looks like this, or you have a matrix that looks like this, let's call them M. The only difference is all the columns can be different types. Okay, but we have this many rows, we have this many columns, we have this many rows, this many columns. They all have exactly the same type of cells over here. Okay, life is good. But we can go and do this. We can say, I can take my matrix and I can say matrix of give me the first 4 rows and give me all of the columns. Okay, we talked about this before. All the same rules. Again, we apply the same rules for one-dimensional subsetting in each of the two dimensions. That's why we needed this idea of nothing being, give me an empty dimension subsetting, means everything in that dimension. We can quite happily say n square bracket of, okay, and give me and drop out the first column here. So this gives me back everything but the first column. Okay, so it'll remove this, but it'll give me back all those columns and all the rows. Life's fine. Nope, no problem. Okay, give me back all of the values. Okay, and I can use names. They have column names and row names. If I put them on, I can use names here. I can use logical vectors. Okay, I can do things like the following. Okay, just to connect the dots. I can do apply on the matrix, and I can say, here's my function. No, I can't. Lapply, I say, here's the thing I want you to loop over. Here's the function. But this apply is slightly different. Apply says, loop over what? The rows or the columns? So, because when we had a data frame, Lapply said, loop over the columns. It's a list. It was clear what we were looping over. So here I need to say 1, the international symbol for row. Okay? Who would have known? Okay? It actually makes sense because in higher dimensions, we can actually go to 3, 4, 5 dimensional arrays, and then we actually specify which of the dimensions. Because this is the first, we're going this way, and then we go this way, it's 2 with columns. Okay? And now I say, okay, here's a function. Here's a function x. So x will now actually be passed in this block. It'll create a new vector with n columns, elements. Okay? And it'll pass it in, and I'm going to say all of x are greater than 10. Okay? This will come back with a vector with as many elements as there are rows, and this one will be true, and this will be false, and true, and true. And now I can subset M by this. I do this and I say M of this guy, comma this guy, and it only gives me back the rows for which this aggregate is true, that all of them are greater than 10, okay? Or that one of them happens to have the value 2, okay? I can do anything I want. So subset by position, by negative position to omit, by logical vector in the rows or the columns. This is a nice example of apply to actually do this. It works on matrices. If I did this on a data frame, as I mentioned, it would turn the data frame into a matrix, which could have been good or bad, okay? That could be very bad news, okay? If I take a factor in a column in my data frame, I got a factor here. Here's my factor, which kind of is an integer vector, but it's also got these labels. Which is it? Okay, and I have numbers here. I've only got 2 things. What will converting this guy with numeric vector and a factor, what will it turn a matrix into? How do you? But hang on a second. The type of a factor is an integer, so why wouldn't it just?
Numeric.
No, you're right. First time around, you were right. Okay, because we need the labels, we lose information because the numbers 1 to 0 or 1 to the number of levels means nothing. Okay, without the labels. Okay.
Why is it character? Why wouldn't it be numeric? Couldn't you convert integer into numeric?
I could, but the trouble is when I actually get the matrix, I'll have thrown away all the labels for the level values. So now I'll just be looking at 1, 2, 3, and I go like, was that physics? Or was that? It's 2 physics? I can't remember. So it tries to not lose information as the general principle. So then we get back a character vector, and now all hell breaks loose. Okay, so that's fine. Okay, there was somewhere I was going with this. Yes, I know this. Okay, 2 challenges. Get me back. I want to get back this element, that element, this element. Okay, and I know them. Okay, this is position 2, 3. This is position 2, 7, and this is position 9 and 4. Okay, these are rows, columns. How do I do that? Okay, think about that. Well, okay, and I'm going to give you another question, which is, give me back all of the elements in here which are greater than 10. Okay, so all the elements of M which are greater than 10. Or, even better, tell me which ones they are. Give me the row and column for each of them. How do I do the first one? It doesn't fit into our little framework so far. Because we do by row and we do by column. So it would seem somewhat natural. Is everyone with me about the question? No? I want to get these 3 numbers. I want whatever's in there. I want those actual values. There's a horrible way of doing it, which is to actually know, which will help the second question. I told you this earlier as a matrix. Okay. This guy here is actually a matrix. It's not. If you look at the attributes of this, it's actually, if you take a look at the type of, it's a numeric vector. Let's say those are all numbers. It's a numeric vector, and the attribute is, it's got a class called matrix, and it's got a dimension called, it's got an attribute called dim, which is a vector of, an integer vector with 2 numbers, the number of rows, the number of columns. And that's how R knows to print it as rows and columns. It also may have another thing called dim names, another attribute called dim names, which is a list with 2 elements, the row names and the column names. So that's how we could subset by name and column name, row name and column name. But it is actually a big long vector over here. And I actually know that they go like 1, 2, 3, 4, up down to n row, and then n row plus 1 is the next one, and so forth. So this is the first column, then this is the next column, and so forth. So I could actually do some arithmetic to figure out how to get indexed. Okay, every time I do this, I have to go, hang on a second, I need a piece of paper. I'm going to actually have to work this out. I know the formula very well, I can never remember it. So this is kind of annoying. You don't want to do it this way. This is cheating. Okay, what we actually want is this. We want to be able to do something like M of 2 and 2 and 2 and 9. 2 and 9. So let's put this together. And C of 3 and 7 and 4. Okay, so the 3 goes with the 2, the 7 goes with the 2. I got it all right. What will this give me back? This will give me back the second row, and the 9th row. And within those, it'll give me back the 3rd column and the 7th column and the 4th column, which is, so it's going to be a 3 by 3 matrix, which is not what I wanted, because I know there's only 3 numbers, so I know I'm immediately wrong. Okay, so this is not good. Now, watch this trick. Take those 2 guys together, C-bind those 2 guys together. Now I've got a matrix with 2 columns. 3 rows, 2 columns, yes? That's just what C-bind does. It tries to, it's like C, but it tries to combine them as columns. Now, okay, so I've basically got this, 3 by 2 matrix. 3 by 2 matrix. This is critical. I can have as many rows as I want, but I got 2 columns. And now I do M of this. And that will give me those 3 numbers in that order. Okay, in the order I specify them. So I'm subsetting by a matrix. I never mentioned that one before. I had it on the page, but I never mentioned. We're subsetting by a 2-column matrix where the rows of that 2-column matrix give me the I and j coordinate, or the ith row and the jth column for the element that I want. This is extremely handy to be able to go in and rip out the values that we want. Okay? Yep.
Do you only use it on matrix?
Yeah, you can use it on a data frame, but then they'll be coerced into a matrix, which is bad news. Okay.
And then you don't need. Then you have to use
You can create the matrix. You can create a 3 by 2 matrix any way you want. However you create that matrix is your choice. This is a convenient way where I know the row numbers and I know the column numbers, so I'm just going to combine them together. Okay? So, and here's this, I've written this down in the matrices from the day 2 notes. They're kind of in some things I wasn't exactly sure what order we get them in. There's this other trick we can do, and this is a fun one, okay? So that this is subsetting by an n, let's call it n, okay? An n by 2 matrix, okay? The 2 columns is critical here, okay? If you end up with any of the values more than number of rows, bad things will happen. You'll be subsetting into and getting NAs coming back and so forth like that. Likewise, if you subset by negative numbers, what do you mean? Probably not a good idea, but we're subsetting this. Now, let's go over to here. There's another thing we can do is this. Here's n. Oh, sorry. Let me second. Here's x. Okay, here's an any vector x, and we said, oh, give me all the x's that are greater than 0 or greater than 10 or that are between this and that or that aren't equal to a, b, c. Any logical vector. I get a logical vector like this. This one's true. This one's true, and this one's true. I put this on top of this guy, and I pull out the ones that are colored. Okay, so when I put this mask over this, I get this guy, I get this guy, and I get this guy, but not those guys. Okay, everyone happy with that? Logical subsetting is just get the ones that are true. So, let's do exactly the same thing with a matrix. Let's build a 2-dimensional matrix with exactly the same number of rows and number of columns as this, and let's make this trues or falses. Okay, we pop them on there and we subset by that. Okay, everyone happy? So it's exactly, this is analogous to the 1-dimensional case, we just have the 2-dimensional case. There's a nice built-in function that does this. Row of n, for example. It's a really boring function. What does it give me back? 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 2. Okay, it just tells me what row I'm in. Okay, and all of these, everything in this row is in row 2, and everything in the, okay? And there's a corresponding call. And now I can do things like, hey, show me all the rows of n, which is greater than 3. Okay, take this guy. Well, now I'm doing this guy, and I'm basically saying it's greater than 3. So this is false, 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 true, 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 false, sorry, false, false, false. The next one is true, 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 or greater than or equal to, we'll say. Okay? So we'll get back a logical matrix back, and now I can subset. So there's a nice little trick. We can say, show me all the guys for which row of M is greater than col of M. What's that going to give me back? Oh, the other way around. My heart. Okay, but okay. So we can actually go in and pull these things out. So we can actually construct. We can construct logical matrices and then subset by those as well. Okay, but now instead of them being with 2 columns, they have to have exactly the same number of rows and number of columns as the original matrix. Okay, when do you use these? Whenever you're using matrices. I told you don't use matrices very often, but sometimes they can actually be useful, okay, for certain things, okay? But I also phrase this question, give me all the elements in this matrix which are bigger than 10. And this is one way of doing it, and actually we need this for certain types of questions to actually construct a matrix mask, if you will, that we superimpose on a matrix. But what's another way of doing it? Use switch. Yeah, I could use switch, but I actually want the elements themselves, so I can do that too. Let me just do one. Remember, I told you it was a big long vector. So when I do this, when I go in and to put this logical mask over here, and I pull out this entry here and this entry here, I can't represent it as a matrix anymore. It's lost its structure. Yes, I mean I'm coming back with, in this case, 1, 2, 3, 4, 5, 6. I come back with 6. So this is let's say that this is a 5 by no, let's say it's a 50 by 10, and I got 1, 2, 3, 4, 5, 6 elements. There's no way I can put that back into any meaningful matrix. I mean, I could put it back with the values with NAs all over the place, but that doesn't make any sense to me. Okay, I can ask where are they, and this helps me because now I can do which on this logical vector. Okay, this logical matrix. But if we think about this, this is one big vector. I can just say, hey, M, give me all the guys which are bigger than 10. And I get exactly the same answer. Okay? So sometimes it's useful to be able to do it this way because a matrix is just a vector. So we're just saying which elements are they? And if I really care about which rows and columns, then I can pull this out with logical values as opposed to trying to understand this weird structure of it. Okay. Anyone with me? Any questions? So these are matrices, okay, and how you actually do. One of my goals here is to tell you everything you're supposed to know about the fundamentals of R. Okay, even whether you use it or not. Okay. Do you use matrices? I hope not. Okay, because they tend to be an accident. Okay. Yep.
Can you do multi-dimensional matrices?
You most certainly can. You have to create them. I will, thank you. Can you construct multi-dimensional matrices? We have 2-dimensional matrices. You can have 3-dimensional matrices where you just stack a bunch of matrices. So you might have a time series. You have a matrix for time 1, time 2, time 3, times 4. You can do, I can't, 4-dimensional matrices. Okay, there's no, you can go to any dimension that you want. Okay, and life is good. Okay. So you can go into that. These are called arrays. You would construct them with the function array. Now you have to and you just give it a big bunch of numbers. Okay, these are all the contents, and then you tell it the dimensions. And the dimensions is not 2 dimensions, the number of rows and columns, but actually a vector with as many dimensions as you have. Okay, and they're again stored column-wise, so you have to understand what that means. And then when you start subsetting. Remember I told you you have 2-dimensional subsetting, so the number of you subset by the rows and then the columns. Well, now you have 3 dimensions. And if you take a look at this function, okay, we look at that square bracket. And this one's very annoying. Okay, so let's take a look at the help on this guy. Oh, I'm in ESS. Oh, that's not good. Hang on a second. Let's go over here. Okay, so there. So when you subset, it's got I, J, and dot, dot, dot. And that means you can specify the 3rd, 4th, 5th, 6th, 7th, 8th dimension, and no problem, as long as it makes sense. And these drop, by the way, are very important. when I ask in a matrix, in a data frame, give me the first column. Remember we talked about this? I said, when you use square bracket, it gives you back an object of exactly the same class as the thing you're subsetting. But if I take a data frame and I ask for one column back, R thinks you probably would prefer the vector, not the data frame with one column. So you say drop equals false, we'll actually say, no, keep it as a data frame. But by default, drop equals true. Okay, and likewise, when you're subsetting a factor, so I say, give me all the physics or geography people and no one else, but R by definition will keep around all the other levels, because really they're still legitimate values. If you ever want to shove something in there, it should protect you against making an error. But sometimes you basically say, look, I really don't want to be carrying around all these different extraneous levels. So you can say drop equals true or false, and then that will actually control whether we drop the extra levels. But you can do multidimensional arrays. And when you do an apply on a multidimensional array, we have this apply function where you did it by row or column as to which you loop over. You can do it in multiple dimensions. You can do it in 1 dimension, 2 dimensions, 3 dimensions, 4. So you're basically collapsing over different margins. And when you're doing that, you really need to think hard. Okay, it's very hard to think about multidimensional arrays and get them right first time around. Any other questions? Yes.
So you are doing a simulation study in which you have, say, 10 factors with 10 conditions in each factor, you're going to a huge data structure. How would you store that as a list, as an array? What is your
okay.
You want to do things on each condition.
Very, very good question. So basically, I've got. Let's simplify it. We've done a simulation. We got three different things we can change. Okay, tell me when I'm going wrong here. Okay, so it can either be A, B, C, and then we can have another condition which is X, Y, Z. Okay, so we're sort of controlling, I don't know, whatever it is. Okay, so. And I get back a matrix, let's say, or I get back a data frame for each simulation, for each setting. Now, I'm probably going to do multiple simulations as well, so I'm going to have multiple repeats. Okay, so how do I store this? The answer to that question is I have no idea. Okay, because I don't know what you're going to do with it next. And the way you decide how you're going to store your data, it depends on what it's going to be, in what form will it be most convenient to do what you do most with it. Okay, if you're going to do something with once, that's going to be very complicated. Well, then later on, we will transform it to that weird format that function requires. Okay, but most of the time I'm going to actually do it, do the same thing over and over again with it, then I'm probably going to leave it in that form because it'll make my life simple. So you could, so in this case, so what will it be? Okay, so what are we basically saying? So first of all, how do you actually construct this thing? Let me just, okay, so you've got conditions. So you've got condition 1 is either A or B. Okay, and condition 2 is either high, low, high, medium, and low. Okay. By the way, we may have in factors, when we have factors, sometimes you start with a real valued or integer valued number, a variable, and sometimes we convert them into these categorical values, in this case an ordered categorical value, using the function cut, that actually we sort of say, look, I don't care about the individual values, I care about which bin they're in, so factors come out naturally in this. So we got these two things. So I bet you do, when you're doing your simulation, you say for I in A and B, okay, put quotes around them, yeah? This is what we do. And then we say for J in C of high, medium, and low, put quotes around these, okay? This is how we often do our loops, and then we do something in here. So then we say for N in 1, or for K is in 1 through num replications. Okay, we can do this. Okay, here's another trick. Okay. Sometimes it's good, sometimes it's bad, but it's kind of nice to know about. Let's do this. Expand dot grid of condition 1 against condition 2, condition 3, condition 4, condition 5. This will give me back a matrix of all possible combinations of A with each of these and B with each of these, and if there's a third condition, that's great. And then I go ahead and I go apply. Okay, apply my function that does the simulation for each of these inputs. Okay, this is a more R-like way of doing this. Okay, so rather than a bunch of for loops. Okay, because this kind of gets annoying when I have 10 conditions. You said 10, I think it was 10 conditions. Oh God, I've got 10 loops here. And I got an 11th loop, which is the number of replicates here I have. So how would you represent this? One, you've also got to figure out where you put this. So you have to store the values in, and you can easily put them in different places. You can put them into a list, as you say. You can flatten the list out to be where the names of the list are A, comma, high, comma, 1, comma, 2, comma, 3, up to the number of replicates and so forth. Another way to represent this is the following. Suppose you end up with two outputs, X and Y, or anything we have, okay? These are the measurements that you get. So for each of these guys, you get back a matrix that looks like this, and we have n of these guys. Maybe it's different for each run. Okay, we have X and Y columns. So what I could do is I could put the XY in here, XY in here, XY in here, okay? Always two columns. Okay, so this is for simulation. These are the first, these two, we did 2 replicates. There's only 2 replicates. We have 2 replicates here. Okay, great. That was for, this is for when we had condition 1. Condition 1 was A, condition 2 was A here. Condition 1 was A in both cases. Condition 2 was high, high. Then down here we had 2 replicates, and this is for A, but this is medium, and this is medium. And this is another way of representing this data. This is in long form, okay, rather than a list or anything like this. This is a data frame we're actually constructing. And now what I can actually do is I can do operations on, give me all the A's, or give me all the subsets of X's where A is this, and condition 1 is A, and condition 2 is H. Okay, so I can do these group bys, okay? So that's another way of operating on these. And if you're going to be using ggplot2 or lattice or something like that, this is the way you want to construct your data. If you give ggplot or lattice a bunch of lists and say, you figure out the connection between them, you're toast. Okay, so you kind of have to put them into this format. And this is a very convenient format. It's very long, okay, but that's the nature of the beast. Okay. So that answer your question to some extent, but you do have to give it a little bit of thought as to what you want to do with it. But this expand doctrine is useful. Yes, somebody had a hand up. Yep.
This one, if you're using that structure, where you say 4, J, C, 3, 3, 5, is there like an underlying integer? You pull that systematically?
No.
It's just using it.
No, J is going to be H and M. So oftentimes we'll see people do the following, which is for I, for J, in this case, for J in, and again, remember, sequence along equals cond 2, okay? So this is now saying, make a sequence as long as cond 2 is. So this is cond 2, I defined these up here. I didn't really, but okay. So this will now be J is 1, 2, 3. And now we can use that to go back and put them back in the right spot, if you will. So we have a list. If we had this nested list structure, but that we have to set that up ahead of time, and that would be confusing. We try to stay away from this because this is much easier. This is a flat structure. This expand doctrine. When we're passing in here, we have a function here that gets basically P for our parameters. It's a matrix, so we get to see that P is A and H. Okay, we got a vector of A, H, and another one is B and M, another one is A and low, and we can read those off and actually then just go and do something with them. So we're flattening out this. And again, this works. I can put in cond 1, 2, 3, 4, 5, 6, 7. This grows however many I have, whereas this, the nesting gets very unfortunate. Okay. Yes.
Sorry, so I'm confused there on that. And that last way, so what do you want to return from your function there to be able to get that form? Are you returning
at the end of this guy, what this guy is going to do is going to actually construct, let's say, my matrix of X and Y. It's going to give me back each of these individual things. And then what I'm going to do, so you can do it with for loops, and the one thing I will say is get it done the way that's most obvious to you. Then when it falls over and it won't scale, okay, because you now have a million conditions and you go like, I have to finish my PhD in 3 years. It's going to actually take me 3 years to type in the for loops, okay, let alone run it, okay? And then we start becoming a little more intelligent. But no, do it the dumb way. But what this is doing, what I want this to do is to return these guys, okay? So I will get back a list of matrices, okay? Each of these will be X and Y, X and Y. They may be different lengths, that's okay, but I'll get back a list of these guys. And now what I want to basically do is I will do the following, is I want to row bind them together. Okay, so we saw C bind for combining columns. This is row binding, so it stacks them on top of each other. Unfortunately, the R bind function is actually, if we take a look at it, R bind basically takes A and B, and it stacks A on top of B. Okay, so it takes this guy, and it gives me back these two. But it doesn't. I can't put in a whole bunch of them. Well, I can, but I don't know how to type this, okay? But now we have this magic thing which we saw last day, I believe. This is my list, okay? So this thing came back from the apply. Here's my list of all these matrices. I want to stack them on top of each other. I want to call rbind, and what I'd really like to call rbind with this, rbind, I would like to do this. Rbind of this guy, comma, this guy, comma, this guy, comma, this guy, comma, this guy. But I'm not here to type that whole thing out. So I'm able to say, hey, can you call rbind with this list of arguments? So eventually go in and do the matching of all the arguments, and these guys will get passed into ... Okay? And then rbind goes, oh, I can do that. I can stack them all together. Does that make sense? Okay, so this do.call is a really handy way. When I don't want to actually pass the argument in by hand, but I actually already have them in a list, do.call is your friend. Any other questions? Yeah.
Can you please give an example of this with code, the standard and stuff like that?
I can. I'll have to come. I mean, I just did. Somebody asked me this recently, somewhat recently, is that was the answer. So I'll think. But yeah, I mean, basically, it's just as you're looping over different conditions. I mean, what you're basically saying is, I want to vary these. I want my first condition to have these two possible values, and I want to go through every possible combination of this second condition. How do I do that? I can do it in a loop, but expand.grid does that for me. Okay, and we're running out of time. So let me just. There's a bunch of other stuff that I want to get to. We'll do it on Thursday, which is fine. I talked about the apply functions, but I don't believe I mentioned the mapply function, did I? I mentioned it, but I didn't explain it. And I also didn't explain the tapply function, but I talked about it as tapply is the following, okay? And mapply, okay? So we'll come back to the tapply. Oftentimes what you want to do is the following, and we could do this in the same vein here. Expand.grid could create this enormous big grid, okay? Which is fine. But sometimes what I actually want to do, and I kind of basically need to do that. So let's do that, okay? But sometimes when we do the lapply, what we basically want to do is we say x, and we apply a function. And remember, it just basically takes my x, takes each element, and it calls fun of x square bracket I, and puts the answer back in the list. Yes, in the answer list, and we're done. In many cases, we actually want to loop over 2 or 3 or 4 or 5 or 6 or 7, okay? We want to loop over these guys, and we want to pass these 2 arguments to fun. So I want to basically call fun of x square bracket I, but also y square bracket I, and z, and okay, anything else, okay? Plus some additional arguments that don't change, like we did with the na.rm equals true and so forth. So we can't do that with lapply. Lapply takes, if I do lapply x, fun, and y, it passes the whole vector of y into each call of fun. And this guy has no idea whether it's being called on the first element or the last element, the middle element. It cannot tell. So there's a trick you can use, which is annoying as hell. Okay, we do it all the time. So tell me what's wrong with this. Lapply. So instead of doing this, we say lapply of 1 through length of x. Okay, and now what I do is I say, here's my function. It takes I, and now we say, here's my real function, and it takes x square bracket I, and y square bracket I. There are so many things wrong with this, it's sad, okay? That will work though, won't it? Basically, instead of looping over each pair of elements and passing them, we're basically looping over the index of each of these, going and grabbing the ith element and passing them explicitly to fun. Okay? So what's wrong with this? Give me, what's the first thing wrong with this? Pardon? Sec along, okay, this doesn't wrong, this is wrong, okay, because if X has empty, if it's empty, oh, by the way, what else is wrong with it? Okay, so now I'll give you sec along.
Is it creating a new call space for each function of I?
Oh yeah.
And then looking up fun, and then looking up what X is.
It's got fun actually. It's fun is already given here. That we're actually, this is one of the reasons why for loops are slightly less efficient than this, because fun is found only once. So we've already locked down fun, but we are going in and doing the subsetting. Sec along equals X. Okay, go back to this is better than that because we talked about the fact that the 1 colon is wrong. What about, could I change this to sec along equals Y?
Yeah.
No, not if they have different lengths. The recycling rule isn't being done here. I'm doing it myself. So if X is smaller than Y, I'll only loop over the elements of X and stop. So I really should put in I should check which one is longer and then force that, okay? So that's kind of, so I'm going away from this, okay? And then what about the extra arguments, dot, dot, dot? I need to put those guys in here, over here, dot, dot, dot. So life is fine here. We are doing all this guy. What if Y is actually smaller than X? What happens when I go and ask for the second element when it only has 1? Okay, I'll get an error because I'm subsetting a list. So, oh, good. If it's a vector, it's okay. I'll just get missing value. Oh, good God, I'm not getting the recycling rule at all. So this is all very bad news. So mapply. What do we do with mapply? We want to do this. We basically want to do this for each pair of elements going in here. So we type mapply, and we type X, and we type Y, and we type fun. Is that right? Happy? Don't ever do that, okay? It's fun, X, Y. Because it has to be, because we don't know how many of these are going to come next, so these are in the dot, dot, dot. This one has to be given first. Oh, God, hurts my head. Okay, I have to remember that, okay? Now, how do I pass? So this is, I can pass down any number of them, X, Y, Z, A, B, C, D, E, F, G, okay? Any number of variables, and it will just go through them. So use the recycling rule, life is great. Okay, so how do I pass down the extra arguments that don't change in each call, like the na.rm equals true? Can I just type that? Fun xy na.rm equals true. Let me just show you the mapply function so you're happy. There's a hint here, more args. And the reason is if you type na.rm equals true here, it'll go into dot, dot, dot as an extra argument, won't it? It won't go down to each call as na.rm equals true. It'll go down as, oh, I'll just expand that vector to be the same length as X, Y, and all these other ones because it gets put into dot, dot, dot. And this guy's looping over dot, dot, dot. Sorry, it's basically, it's taking the elements out where from the dot, dot, dot. So we actually need to say more args equals, it's a list, and here are the arguments, either by position or by name, okay? So it's more, it is flexible, but you have to be careful, yep?
Can you also wrap that in na.omit? Produce the NAs and then omit them afterwards?
It depends on what X and Y are. I mean, if you may have to glue X and Y together to make a data frame and then call na.omit, or else you could na.omit on each of them. But na.omit on each of them is different from na.omit on them simultaneously. So you have to be careful. Yep. Okay. So this is mapply, and it's very powerful. You'll see also there's a thing called map, which does the same thing. The big difference is this. This tries to simplify the result. Sometimes you want that, sometimes you don't. Be careful if you don't. It'll create a vector or it'll create a matrix. And if you wanted it as a list, you better not let it collapse the things on your behalf. Okay, so hopefully I'll see you guys back here on Thursday, if I haven't scared you all the way. I've thrown up a list of topics that we'll cover. Again, suggest any more. Okay, I'm going to tell you a little bit about writing functions. It's all blatantly obvious, but we'll talk a bit. And also, if you take a look at the web, if you take a look at the Git repository, there is an R package there. It's got one function, two functions. I tell a lie. Two functions that show you about writing R packages and also even S3 classes, and we'll talk about those because they're very important. And any other topics, but we'll have fun for the last day. And you ask me any questions you like and see if you can stump me.